Good evening and good morning. Welcome back to fourth track of Bangalore Technology Conclave 2020. This track is on ethics in AI. In this track, we have exceptional presentations from tech service and leaders across the world, like Katina Michael from Arizona area, USA, Narayana Subramaniam from India, then Dr. Amardeep from San Francisco Bay area, USA, Dinesh Kumar from India, and Neil Hota from California, USA. These five key speakers we have in this particular track. Now, it's a pleasure to introduce Katina. The title of the presentation is Control, Care and Convenience AI-based applications and levels of invasiveness in body, on body, or external. The speaker, Katina Michael, is professor at Arizona State University, holding a joint appointment in a school for the future of innovation in society and School of Computing, Informatics and Decision System Engineering. Now I'll welcome Professor Katina Michael. So ma'am, now you take over and now you are the presenter.
Thank you very much, friends. In Bangalore in India, I'm hoping you're having a wonderful day today. Professor Divya, I'd like to share my screen if possible.
Oh, should I play the... Okay, ma'am.
Ma'am, just drag drop that ball across your name to Professor Katina. Yeah. No. Professor Katina has a presenter rights. Yeah.
Okay.
Wonderful, thanks. The first thing to say is thank you for your time and thank you for your energy in bringing together the Bangalore Technology Conclave. I'm very happy to be talking on the ethics in AI space. And today what I want to focus on are three areas of application that will be very much inspired by artificial intelligence. That's control, care, and convenience applications. And the way we'll be analyzing them today is within the context of in-body devices. So we have three types of devices, really, in context. Operational scenarios. We can have a device that's in the body. We can have a device that's on the body, like a wristwatch, or we can have a device that's external, somewhere away from our personhood. So control, care, and convenience applications that are powered by artificial intelligence. And we're looking at the three operational scenarios: in body, on the body, and external to the body. And we're going to be focusing on an emergent technology that has been around for about 25 years in the non-medical space and over 70 years in the medical space. That's microchip implants. So I want you to think about heart pacemakers. I want you to think about implantable diabetic pumps and insulin pumps. I want you to think about defibrillators, cochlear implants in the ear to help the people who are deaf to hear. And I want to now take that from the context of biomedical and place it in the context of control, care, and convenience for non-medical AI-based applications. So imagine in the future that it wasn't just a wristwatch I was lugging around or a phone that I was holding and taking with me or placing in a Nike band and going around, or a Fitbit. But in fact, these devices became miniature enough to actually be placed in the body. And they would be responsible for transactions, they would be responsible for diagnostics, and they would be responsible for even access to entertainment services. And so what we're doing is we're seeing technology coming closer and closer and closer to the body, into the body, okay, trespassing the area of the skin. And what we say here is it is about control, care, and convenience. And the whole presentation today will be looking at what I think is going to be the next big thing, which is tiny machine learning, and encapsulating code right? Not only onto our mobile device, but onto devices that we can possibly swallow, devices that we can inject, devices that we can place in the pores of our skin so they enter the body, okay, through different transformations and transitions. Again, I'm part of the School of Computing, Informatics and Decision Systems Engineering at Arizona State University, and I'm in the Society Policy Engineering Collective. I actually direct a research group that is mainly made up of joint hires. So if you need to contact me, it's katina.michael@asu.edu. Today's seminar outline, we'll be looking at the different usability contexts that we described: control, convenience, and care. We'll be having a brief discussion on application quality and service support and the commercial viability of something like this, and then further research. And I need to underscore here that the majority of the research that I'm presenting to you today was actually conducted in the late 90s and early 2000s by myself and a young undergraduate researcher, Amelia Masters, at the time at the University of Wollongong. So we saw the birth of the human transponder implant, that in-body AI-based application device. And a lot of the patents for this human implantable came around the mid-80s. You can look at the uspto.gov website and look at patents by somebody called Mann as a surname, M-A-N-N, and you will find a series of these RFID transponder solutions. The company, very cheap at the time, that was on the New York Stock Exchange, also had a number of these patents. And the patents were very geared towards personal health records. PHRs is what they were termed in acronym at the time. And so the implant was supposed to be marketed as a mobile business application solution. It was dubbed the ultimate identifier. You know, think about Aadhaar in India. Think about taking that Aadhaar device or that number and implanting it into the body. And of course, this raises a great deal of fear traditionally among older groups of people, your baby boomers and your Gen Xers. But as younger and younger generations have come forward, we are now seeing contactless devices and frictionless devices. People are wearing ring bands now to actually go and tap on and tap off. We're using contactless smart cards to transact, and many of us don't know what a check is anymore. And in fact, we don't even use cash. So there's this movement towards a paperless society, a cashless society, but that raises a great deal of ethical questions. So here we have the capacity today to implant a tiny device that you can see in the top right-hand corner. In fact, that was a very large device, but it was one of the first 1.0 implantable devices in the form factor of a transponder. And now we have things that are much smaller. In fact, we even have investigated and researched devices that are like a speck, literally a speck. Many people now wonder whether these specks of devices can be utilized to do anything such as identification. The truth is they can, but the other truth is they are not widely available for the commercial adoption. But where are we going with these ubiquitous devices? What are the advantages of having something not transferable? For example, I can take my phone and I can give it to my daughter to make a phone call. But with these implantables, you can't actually remove them from the human body to make a transference of a transaction. It's you and only you. You know, I can take off my ring and give it to my daughter and say, transact with my RFID ring. But I can't do that with something that is fully embodied within the human space, right? Within my body. And so the other thing is it's invisible. We don't know the characteristic of the transponder someone may be carrying in the future, and it may have a multiplicity of capabilities. If we believe Elon Musk, for example, and that's an extreme example, quite possibly the implantables in our brain will be able to give us more capacity and capability and functionality than we have as able-bodied human beings. So this notion of amplification and this notion of enhancement. So with you wherever you go cannot be stolen or misplaced. And so we spent a long time defining what are the potential intended users? What are the specific users as well of the device, and what are the constraints? And in this context of control, what is control? Control is a dynamic notion. It's based upon knowledge of a desired outcome, upon the processing and distribution of information. And control is defined as those situations in which human use of an implantable RFID transponder allows an implantee, the bearer, to have power over some aspect of their lives, or allow a third party to have power over an implantee. If I give you an example, I've currently got a light bulb switched on. Well, imagine I walk into a space, I have an implantable device. The context around me is ubiquitous in the sense that it knows, and it's ambient. It knows that Katina has walked through the room and she likes the color less light. Whereas if my daughter walked through the room, maybe she likes a softer purple light. And so the context is aware of us based on the device that we are carrying. We have some control over the environment around us. We also can give up some of that control to loved ones. If I was someone with a disability, for example, perhaps I would give someone the control to act on my behalf, or I could harvest the implantable device to enter my front door. I have control over an apparatus, or I give over control to somebody because of my state. And so convenience can be defined as those situations in which human use of an implantable RFID transponder increases the ease of a task for the implantee. So we've moved from control, now we're going to the convenience market. You know, imagine we didn't have to carry around credit cards. Imagine we didn't have to have a purse or a mobile phone. We could simply take our body with the implantable device within and tap and go, right? And these things have been trialed in many different places. We've looked at athletes who are training for the Olympics who had implantable devices. We've seen car owners go up to their vehicle and say, I don't need to carry keys or a key fob. I can just turn my car on literally with my fingertips when the implant is within the webbing and forefinger of my hand. For other solutions, maybe I want to pay at the point of sale without having to carry additional paraphernalia, and then mass market homeowners, the convenience of going into an office space with your device that is fully immersed and implantable. So security controls. Let's look at an example where there's an alert system, maybe a missing child. So it's all about the control of your data. The management side of control, maybe it's about access control and permissions to physical spaces. What about the notion of supervision and monitoring in the workplace? What might that mean? Accessing records within an organization, perhaps when I'm using the photocopier or other things like the 3D printer or a color printer, and I require to authorize through some control level through the implantable. When I go to work and when I leave work, literally that would be seamless rather than having to punch a card in or use a biometric to actually put my finger on a reader. Social controls, ways to conduct enforcement, perhaps in the military. Military personnel use and carry dog tags, which are external. If a military personnel officer was captured by an enemy state, the dog tags actually describe a number and they describe a name. The question is whether in an implantable context, these dog tags would be much safer for the military personnel. And so we're looking here at names, ranks, serial numbers, and the like, whether somebody has an allergy. All of these things could be immersed within the human body. Of course, raising a whole bunch of ethical concerns and legal issues and privacy matters. Punishment. We've seen satellite surveillance technology, even back as far as 2002. 27 out of the 50 American states were using some form of satellite surveillance to monitor parolees that were out and about in the community. Well, now that's 50 out of 50 states. And the economic benefits of perhaps tracking people, particularly in the context of offenders against children, when they're serving their sentences from home or when they're rehabilitating back into society after serving a time in prison. Again, sometimes they are using tracking bracelets like those that are anklet or now we are seeing the potential considerations for implantable devices to reduce the stigmatization of the individual back into society. For crime prevention, infant protection systems, in some, for example, hospitals in England back as far as the early 2000s, children had the plastic band when they were born around their wrist, but that became also very much RFID linked. And the question was whether we would go to the next stage to ensure that babies were not accidentally swapped at birth by placing an implantable in a child. Of course, there have been many concerns about this question, particularly a newborn, for many different reasons. And again, finally, what about implants for airline crew? Traditionally in the 90s, we saw a lot of hijacking and terrorism. Is this space where suspected terrorists or suspected criminals may well be implanted based on historical offence, criminalisation, and other aspects? I have talked to numerous people in airline industries that think that would be a great idea to ascertain who's on the plane and what is their background. So the area of convenience. So we've gone from control and now to convenience. We're talking more about automation of services and assistance, right? So repeated control of a process, linking the implantee with appropriate data. For example, I may have a very safe service and I have an implantable, but I don't want to be left without my luggage. How is it that I could correlate these services together using a simple implantable device? Often when we are stuck at airports, we see hundreds of pieces of luggage sometimes thrown. If there's been a delay in a plane or it's extra large carry-on, we are trying to find our luggage, and a lot of suitcases look the same. The question is, can we create services of this nature? And combining indoor or outdoor positioning systems with actual implantables for consideration for caregivers. For example, wander alerts, where a wearer moves outside a particular boundary, say a dementia patient, and they have moved beyond the predefined boundaries, the safe space, the home, and an alert goes back to the carer to actually find the missing person. Buying and selling, banking, these are other uses of what we call convenience applications of implantables. Interactive applications, where we look at intelligent buildings. A door knows I'm approaching, it opens. Interactive objects like vehicles, and communication even, person to person. And some of the earliest trials around the late 90s and early 2000s were about the potential for more than one person to be bearing an implantable device and not requiring a mobile phone to communicate. In fact, the company I used to work for, a telecommunications company, in 1998 said these would become obsolete, that we wouldn't require the power of these devices to be lugged around. Of course, back then they were in the form of bricks, but as these have become smaller in the palm of our hand, there are also these feature phones that are so small. The question is whether these devices could in some way be implanted into the human body to release us from the burden of lugging the devices around. And we can only do this now because of the onset of machine learning, because we have brought technology on the edge closer to us, whether it's in our immediate environment, whether it's a PowerPoint, whether it's a hub device, whether it's a lamppost externally or a kiosk. And so the question is whether we require power to be always on, or when we come close to environmental artifacts that trigger a device within us to do things. And so potentially in the future, I may be tapping onto my skin, okay, if I have some kind of light source on glasses. And those glasses may be interacting, carrying the battery power and the intelligence that we were previously lugging around on our telephones, but carrying them somewhere, wearing them. And then the in-body scenario interacting with the external on-body scenario. And of course, then we have these other external infrastructure. So your body area network taking over, really communicating with those wearable devices and those implantable devices, both medical and non-medical, for interactivity. And finally, we have care. So going back to the control aspect, the convenience aspect, and the care. And in care, we're talking mostly about personal health records or medical health records. We're talking about having critical information available to us just in time. For example, say I become incapacitated. The whole idea of the very chip back when it launched in 2002, 3, and 4 was to actually allow paramedics to come to your aid and to know whether you were suffering from an allergy. So if you weren't carrying a band with the allergies on there, how else would a first responder know that perhaps you were anaphylactic, perhaps you suffered from, lived with epilepsy, perhaps any other context. And so what happened at the time through the standardization process, the very chip created a standard for a right arm in the tricep for an implantable device. So 900 hospitals back in 2006 were given these readers for their ambulances and paramedics to carry. And so the first thing they would do if someone was allegedly found incapacitated was to scan the right arm. But of course, there were low numbers of recipients at the time. And we're talking now not more than between 5,000 and 10,000 implantees. It's now become a biohacking movement. And rather than it being about control, convenience, and care, today it's really about the cool factor. Biohackers sell the coolness of this approach, it's the fourth C, and have created a whole dichotomy around biohacking. And so in the medical space, perhaps you can see here a wearer or a bearer of an implantable device. They have a fall down alert, a cell tower detects a movement of a fall, an operations center is contacted, the caregiver is told, there's been an incident with your loved one, please can you be dispatched, or shall we dispatch our own personnel? And of course they can do this through a multiplicity of interfaces and desktops. Biomedical sensors and temperature sensors and diabetic sensors, these are more your medical applications for care. And then you've got your therapeutics as well. But in closing, to allow for questions, when we look at the different contexts, control applications, care, convenience, and perhaps the ones that the biohackers are involved with, cool applications, we look at the dominant dimension as being control, whether we're talking about care, convenience, or coolness. The underlying embedded device is all about control. Even when I'm talking about care, I'm controlling things. Even when I'm talking about convenience, there's an underlying factor of control. Even when I'm talking about this is really cool, I can have entertainment services, I can have this and that with my implantable, I can amplify myself. There's still an underlying notion of control. The question is, who will market these implantable devices? Will everyone have this ultimate ID, which will also be really triggerable towards location information and condition monitoring and evidence-based analysis? And if it is companies who have this, if we look at terms and agreements, even of our mobile phones and other devices we lug around, there is the right to terminate a service. And so the company always has the upper hand when we look at the power dynamics and the control relationship. Whether we're talking about control matrices or we're talking about convenience solutions, the company always has that upper hand. And so independent of the type of application, it is all about control. Now, there are many benefits and costs to going implantable. Depending on which life world you're part of, if you see the potential for harms, you will talk loudly about the issues to do with materiality, to do with we don't know how these devices would impact us inside the body, to do with freedom and human dignity and ethics and trust and privacy. And so if every part of our movement, every part of our interplay was productized or was a transaction, then AI would go wild with predictive capabilities, but also knowing you historically and also potentially unleashing biases based on your context. There are many costs to these applications. The lack of widespread reading is a problem at the moment. If we wanted to go this way as a society or people wanted to consent to certain services, the data correlation is a big deal, as I just mentioned. Where do you place the implant? So despite that it was on the right tricep, many different biohackers started to put it in the webbing of their thumb and forefinger. Others put it in their forearm. Others put it on their different types of areas on their torso. And so the question then becomes standardization is an issue. because no one can agree on where these implantables should be on the human body. But perhaps in the future, for medical and non-medical, we will all be bearing these kinds of devices. The question is, how can we ensure that there is no interference? There's a lot of wireless electromagnetic interference at the moment with different implantable devices that we've actually learned from the medical space. So fault tolerance issues, what happens when something I rely on breaks down. You know, I've had a friend today, their phone stopped working properly. And then the question was, I couldn't access email, I couldn't do this, and I couldn't do that. Well, imagine an internal device stops working. You know, at least we can throw things away. Yes, Divya. Yes, we'll summarize now. So what if something was to fail inside the body? So lastly, to conclude, is it a feasible technology? Will the market dictate? We've seen some initial adoption. It's been interesting to say what have been successes and what have not. Factors that would probably trigger mass market deployment, for example, a virus here. I had written that aspect in 2004. And now we're living in a pandemic. And there are many, of course, conspiracy theories about the potential vaccine that is to be deployed. To my knowledge, there is no implant in that vaccine that is to be deployed, but this is the issues that we're raising in ethics. So, Divya, thank you for the patience. We're at the 26-minute mark, and perhaps now we can go to a few questions.
Thank you, Fatima Michael.
No problem.
I just take only one question.
Yes.
How to handle social stigma for implants and microchips? Example, in the United Christianity talks about mark of the breast, etc.
What a great question. Yes.
Yeah.
That's a great question. I think there is a lot of social stigma with technology.
Yes, that's a question. That's it. Yeah.
Yes. There's a lot of social stigma with technology per se, everyone. In some markets, the adoption even of COVID apps have been rendered with some skepticism. The question is why? What are the preconditions for the skepticism? And we see in countries like Malaysia and Thailand, a lot of the vulnerable, underrepresented minority groups, for example, gay and lesbian communities, did not wish to adopt even the apps because they were worried that the location feature on the app would be able to predict where the person had frequented. And so whether it's to do with your ethnicity, whether it's to do with your sexual orientation, whether it's to do with your religious beliefs, as the individual here has raised accurately, this can determine and impact the uptake of technology. And so there is a relationship between our beliefs, our values, our backgrounds, our cultural setting, the mandated government deployment of a service, and the clash with the technology that becomes available. So I think that's a wonderful question to end on, Divya, and I appreciate the person who asked it because I think it's spot on.
Okay, thank you for this outstanding presentation and also various aspects of RFID tracking and also CQ video control care and convenience with this item. And
thank you.
We will, as a token of appreciation, we will give you the virtual momentum.
Oh, that's lovely. Thank you very much. It's such a joy. It's such a joy to speak to Indian communities. I appreciate your enthusiasm.
I'm not a presenter.
You are having a presenter's access, madam.
Yes. Thank you. We'll move on to the next.
Thank you. I'm looking forward to the next speaker.
Yeah. Okay, thank you. Now we'll move on to the next presentation.
Divya, could you please share the pass me the present?
Yeah,
once you're done. Yeah.
Done? Can you see us?
Yes.
Okay, I'll go ahead.
Yes, Divya madam, please go ahead.
Okay, next presentation title is AI/ML in Harmony Engineering. The speaker is Narayan Subramanian. His technology leader are Plenary on next generation hybrid cloud distributed manageability by leveraging the goodness of IoT ML. Now I invite Narayan Subramanian to come to the presentation.
Thank you. Is my share visible?
Yes. You can go ahead.
Okay. Shall I go ahead?
Please.
Okay. Thank you very much for having me today, this evening, on this topic of AI and ethics. And thank you, Professor Katina, for your very insightful talk. I'll probably pick on from the last question that you helped address. And this topic of AI and machine learning and engineering ethics has been top of my mind, although I'm a technologist. But this presentation will probably have almost zero technical material. So I just wanted to set expectations for that. But having said that, it's something top of my mind, and I think it's something that increasingly needs to be addressed by the engineering, scientific, and technologist community, amongst others. It's not just limited to them. So so I have worked in AI and ML in the past, and less so now. So I wanted to share certain perspectives on AI, ML, and on engineering, because I think is absolutely important. Now, just to start off with a quote from Albert Einstein. So when we talk about artificial intelligence, when we talk about machine learning, I see AI really as a marketing term, a lot of times used for ML, right? Of course, also used in other contexts. But the key thing is, and this is a very profound statement that I've always found very useful, is that the true sign of intelligence is not just raw knowledge, but it's imagination. We as human beings are very imaginative, and it helps us in a number of aspects, which I'll come to the next few slides. And imagination is really the glue, in my opinion, that binds intelligence, what we call as intelligence, and what we denote as creative, that is the ability to conceive new concepts and so on. And intelligence is our ability to use existing tools and know-how and knowledge. And it's really imagination that binds both of these things. So let me explain a little more about that, and then as we get into this topic of it. Today's machine learning is primarily, I've just oversimplified it, but it's primarily based off the processing of raw data by algorithms, right? There's a lot of math involved. There are lots of assumptions of math involved. There's a lot of processing of data, and the algorithms are constructed based on mathematical formulations, which require you perhaps to optimize a cost function, some form, or to perform some sort of classification. Whatever it is, it's a bunch of raw data feeding to algorithms to generate a desired output. That's knowledge, right, in my opinion. That's not imagination. Right? And imagination is completely different and requires a huge thing. So when we use this term artificial intelligence in this context, let's not forget the pieces of imagination in it, and why that is very important. What makes us human and distinct from AI, in my opinion, is compassion and empathy. And that is what really makes us distinct as intelligent beings, as creative beings. Right? Compassion takes imagination. And what do I mean by that? Imagination allows us this ability to project ourselves in the past in certain contexts, also allows us to project now ourselves in the future as well, right? So it gives us this ability to visualize or to reflect on certain situations either in the past or project in the future and put ourselves in another person's shoes or another environment or contextual shoe, so to speak, and evaluate the situation from that standpoint. And that's how you build empathy and compassion. That's integral to human, right? And this is not something I don't know. I have not heard of any artificial system that's been able to emulate either imagination, the true sense of humans, and more so taking the next leap of faith into empathy and compassion. Now, why am I bringing all these topics in an IEEE conference? Let me take the next step. In the words of Dr. Albert Schweitzer, who was a very famous physician and, of course, medical doctor, right? Let's focus on this. So compassion, right, is where ethics takes root, right? And it can only attain the full measure of breadth and depth, right, as long as it encompasses all living beings, not restricted to humankind. And this is really a crux of building an ethical human society, which is not only imaginative and creative, which has be able to extend itself to become compassionate, on which ethics is. And an ethical human society really is based on compassion. And that includes us, each one of us, whether we are engineers, economists, scientists, technologists, it doesn't matter. Right? This is a core ingredient for humans. This is what makes us distinct. This is what enables us to identify ourselves with our surrounding and our environment. So I have the next two slides. I have taken a reference from a brilliant presentation by Kai Fu, expert in AI and ML tech talks. Taken the liberty, given the credit, to reproduce these two elements over here. Now, why am I bringing this element of tying all compassion and ethics? The reason is as follows. A lot of our job functions today, right, have dimensions where compassion is needed. For example, in elderly care, teachers, social workers, event planners, where a lot of creativity and strategy is required. For example, scientists, artists, perhaps CEOs, so on. Then there is also the element where there's a lot of quote-unquote optimization required, routine work, right? Where perhaps the elements of creativity may be less, but still compassion is needed at various dimensions. So it could be customer support, could be telesales operation, could be radiologists looking at a cancer scan. Right? And in my opinion, I think the more we start thinking about AI, the more we start looking at its applications, I think these are areas which are worth pursuing first, because humans, we are not built for routine, mundane work, right? We have been trained due to our education and schooling systems over the last 100, 200 years, right, to accept that as de facto, routine, mundane work a lot of time. We ignore the facets of imagination and creativity, right, as we focus just on work. I think this is where AI, quote unquote, compassionate AI, right, helps to free humans from just routine optimized work, where we can now bring about delineation of boundaries as to where AI is applicable as a centerpiece and where AI is an additional tool. So what do I mean by that? So let me term AI as rather artificial intelligence as more as augmented intelligence for an ethical human society, where based on these different functions and dimensions of compassion, of the need for strategy, of thinking, of creativity, based on the need for routine optimized work, right? AI can fit into this and interoperate with humans in different ways, as opposed to just one single monochromatic question, where AI could, as on its own function, routine optimized work where its, blast radius is quote unquote is limited, where more compassion is needed, like in healthcare workers, it's wrapped within the bounds and control of human activity as an aid or assistant, where creativity and imagination is a little more needed. It works with humans to augment the ability and creativity of humans, provide new data sets that allow humans to make better decisions or think of new creative. This is what I mean by augmented intelligence. Now, why am I bringing all these things together? Because it's very important. I think Professor Katina talked about control in the previous session, like related to implantable devices, some of the challenges related to that. As we look at increasing the scope of AI, right, in these various dimensions, it's very important for us as technologists, scientists, and leaders to help define the barriers as to and the guardrails as to where all this stuff is really going to relate to various features and functions. So in today's context, I mean, if you bring me to a webinar, as some of you know, I will always bring in elements related to not just human activities, but related to the environment, natural world, and of course, the present day challenges of climate action, right? So I feel that there are essential guardrails which are needed. What are they? Okay, few things that I have listed here. When it comes to human activities, we saw the last presentation on implantable devices. The guardrails are required for data privacy and governance. Right? Without these guardrails, we are seeing today a lot of data being used, a lot of data being manipulated. It can cause a lot of unconscious social conditioning, which we are seeing in social media, in retail, for example, even in your recommendation engines, kind of start recommending the same things again and again. Okay? This removes the variability and the beauty of spontaneity of human action, in my opinion, in my own personally. Surveillance is good in one way, but you don't want a big brother on the other side. I think Professor Katina talked about that in an earlier presentation. Another guardrail, right, where against data bias, against race, religion, gender, politics, culture, right? Else this can lead to social profiling, artificial economic barriers being created just because of the situation in which you were born or raised in, right? Some samples of these are insurance and financing, which are leveraging some of this, create barriers via pricing mechanisms, which sometimes is unethical. Reinforcement of unconscious bias, right? In echo chambers, we see that very heavily in any form of social media today, and perhaps some of that happening live today as we speak. In addition to that, it's so important for us as we look at AI as a solution, is transparent algorithms and diverse data sets. I think diverse data sets are well understood, but transparent algorithms, when you look at a neural network as a set of weights, it becomes very challenging to figure out what exactly is going on. And then various applications of AI. The first and foremost that worries me the most is the application in military applications, right? Where remember, these are machines, these are programmed, whether you use computer vision, various types of sensors, it does not have empathy, it does not have compassion. We lose that element as well as we use this increasingly in warfare and military applications. Something to safeguard against. Climate action. Why do I bring this? Internet communication technologies are the fastest growing element of electricity consumption across the entire spectrum of electricity domain. Right? There's a great MIT Technology Review article on the carbon emissions related to deep learning and the significant impact that it has. This is also an ethical aspect. As we intrude various algorithms and compute algorithms all over the place to the edge and beyond, right? Somebody has to pay the energy cost. So it's important for us that while we find use cases to do this, we focus on efficiency as well. Environmental impact assessment, right? We need to ensure that whatever be the use cases that we come up with, I'm sure over the last 2 days, there have lots of use cases being stated. It does not degrade further the natural environment that we have, right? And it does not cause, per capita increase in resources. Should go the other way, right? As much as possible, and safety aspects. So there are so many. There are these 3 pillars that I feel while we look at ethics and AI, while we look at augmented intelligence, that these are things that we focus on. Now, why do I bring this energy imbalance and climate change? I think everyone knows about this, that we have, the climate crisis today is because of an energy imbalance that we create. What I really want to focus on is, while we look at increasing scope of AI, increasing scope of gathering various bits of data all across, whether it be via 5G networks, via implantable devices, proximity sensors to collect data, whether you're in proximity to edge devices that collect data, please assess the energy footprint, right? Because ICT is the largest growing footprint related to energy consumption from electricity point of view. And if we do not address this, we are going to be compounding and adding to this problem, right? We are generating various data sets via images, videos, whatever be it, via biosensors, anything, right? Unless we address this, we are going to put ourselves in significant challenge. This is an ethical challenge for the use case of AI as well, in my opinion. That's something that we have to look at, right? As responsible technology scientists and engineers. How do we address this, right? In the words of Nelson Mandela, education is the most powerful weapon we can use to change the world. Just because we are in industry doesn't mean that we don't need to get educated, right? Just because we have degrees. I think as we develop AI systems as for various use cases, I feel 3 things need to happen, right? The first thing is, there are so many advertisements and there's so much encouragement given for young students and children today in advertisements on TV, especially in India, to get into coding and all kinds of stuff. I think folks in India will understand what I'm talking about, right? It is the advertisement that comes between the overs of a cricket match. I think we all know what I'm talking about, right? But we are not educating our students on the importance of compassionately using technology with our limited resources on this planet that will allow us to thrive in harmony with our natural environment, whatever technology that we use. And since AI has an increasing footprint, there needs to be a focus on this as well. Okay? So how do we do this? Few ideas that I have is, the UN Sustainable Development Goals to be distilled and disseminated in schools at various levels, right? Now, engineers, economists, and scientists, while we learn math, while we learn stochastic systems, Markov processors, all that is all wonderful stuff, right? It's equally important for us to learn humanities, arts, culture, physical sciences, right? Which allows us to develop increasing empathy towards society and the natural world. We are developing AI perhaps as a means of convenience, but we have this one planet to live on, right? And one natural world to coexist in. Let's not screw things up even further, right? Now, corporates that employ AI and ML, right? It's not enough to hire smart engineers or technologists or scientists who know nifty algorithms, right? or who can craft out, all kinds of various applications. It needs to be melded with social scientists and environmental experts, educating engineering teams, right? This policing and enforcement is a difficult task. The best thing comes if everyone is educated and builds up the necessary empathy and social empathy across the world, right? So every engineer needs to think, when you are developing an application on AI, what is it that I'm developing for? What's the use case and benefit? And is it harmful to humanity, to the natural world, and increasing towards energy and climate action? All these three are important pillars. I want to revisit this. We are part of IEEE community. This is an IEEE conference, right? The first thing that we have in the IEEE Code of Ethics, I would like to read it out because it is important even in this discussion related to AI. And this is taken from the IEEE Code of Ethics. The first point is, we as engineers and technologists have absolute responsibility to hold paramount the safety, health, and welfare of the public, to strive to comply with ethical design and sustainable development practices. A lot of times we have forgotten these two things, ethical design and sustainable development practices, to protect the privacy of others and to disclose factors that might endanger the public or the environment. As being part of IEEE community, we have signed up for this code of ethics, and it is incumbent on us to follow this in regular engineering, especially in this field of AI and machine learning, because there is a lot of scope for violation, there is a lot of scope for human misbehavior. I say human misbehavior. It is not the fault of the algorithm. It's not the fault of mathematics. It's the fault of human beings in how we apply these tools and technologies in various use cases. That is why we need a holistic assessment with social scientists, environmental experts, and everybody else to make sure that whatever we develop is relevant in a humane and ethical society that we all, I'm sure, aspire to be part of. Okay. As I end, I would like to play a 2-minute video. Okay. This photograph which you see is Earthrise, which is taken by the astronauts of Apollo 8, the first people around the moon. Right? And why I put this picture is AI is having an increasing imprint on our society. It is up to us as engineers and technologists. We cannot rely on government or politicians or somebody else to tell us what to do, what is right. Each one of us has to do what is right. Right? This is our only planet. So whatever we develop from an AI or technology perspective, we need to safeguard that, right? And be it from human footprint or environmental perspective. Okay. So I'm just going to play a short video, and then I will a 2-minute video, and then I will be happy to pass it on to the next speaker or take any questions as they may be. This is that. Yes.
Sure.
Just 1 second.
Sure.
Almost up. My apologies for keeping you waiting. All right. So this is just a 2-minute video, and I want to re-emphasize, when you think of AI and machine learning, please think of this and the impacts that so-called optimization and use cases might have from a business standpoint. May generate a lot of corporate profits, but before you look at that, please remember this video. Thank you very much, everyone, for your attention. If there are any questions, I'll take it, else I'll hand it on to the next speaker. Thank you. Puneet, Divya, back to you.
Yeah, thank you, Simon. And wonderful presentation. I have a lot of issues, pertinent issues related to climate crisis and other factors, and also you are trying to convey or tell all the technologies could be active for computation, like future resources or artificial intelligence. Everything is basically referred for climate crisis with a lot of modeling and algorithms. And let us catch you offline related to the climate crisis, related to the high-performance computing systems and all. Now, I just share a couple of applications on behalf of Bangalore Technology Conclave Organizing Committee and IEEE Bangalore section. Thank you, Narayan, once again for the wonderful presentation.
Thank you.
Now, we'll move on to the next very interesting and unique topic by Amardeep Satya and the presentation title is Trustworthy AI Framework for Business. Basically, Amardeep Satya is Managing Director, Analytics and Publicity at Bangalore. He has 25 plus years of global experience in finance, healthcare, telecom, so on, Fortune 100 companies. I invite and request Amardeep Satya to take up the and on the
Thank you, Divya. Thank you, Professor and Narayan. Thank you so much for your insightful presentation. I need to share my presentation, so you need to give me the share handle.
You are having now access.
Yes.
You can share it.
Okay.
Down below 3 tabs are there.
Yeah.
Mute, stop video, share.
Share is grayed out. Just looking at. One second. Yeah. I think there is probably some privacy setting or something like that. It's on Mac. It's grayed out for me.
Okay, so you can go to the file. You just go at the top file.
Okay. File.
Open and share.
Got it. Okay.
Yes. It's coming.
Yeah, it's loading. Okay. Wonderful. So while it's loading, I wanted to quickly touch upon, I know 30 minutes is a very short time to talk about trustworthy AI or ethical AI. It's such a rapidly developing topic right now in the business world that is almost putting a speed bump on some of the initiatives in AI in many of the large, Fortune 500 companies. And so I'll try and do justice in this 30 minutes. Essentially, as we talk about trustworthy AI, it has got a cross impact across different part of the functional part of the organization, be it legal, be it finance, be it risk, be it the AI teams, be it the data teams. Almost everybody today inside of the organization where AI is being leveraged to drive innovation or disruption in the organization, all parts of the organization are getting touched. So much so, there's a lot of change management that's happening in terms of bringing social sciences, thoughts of diversity into the psyche of the individuals who are actually, data scientists, right? So data scientists and social sciences are really coming together to really embark upon this trustworthy AI. So in this 30 minutes, I'd like to essentially touch upon three things, right? Why is, trustworthy AI relevant today? Okay. Give you some statistics around it. And what are some of the AI techniques that we could actually employ to address some of these issues? So there are some process issues, people issues, but also technology issues. What some of the solutions that we can bring using AI for bringing about diversity into our insights and prediction analytics that we do. And last but not the least, also kind of leave you with a framework which you can then apply to your own AI workloads that you have, right? So going to the next slide. Okay, so if you, we did in 2019, we did a study across 3,000 companies across the globe on what does ethical AI or what does trustworthy AI mean to them, right? 95% of the people that responded, right, or who are early adopters of AI, shared that ethical risk in AI implementations is one of their biggest concerns. And it's a concern because of the liability that ensues in making a decision which can go against the principles of common good. So AI decision-making or AI prediction today cannot be a 95% utilitarian model, right? So it's good for 95%, but it may not be good for 5% of the people, right? 95% people, it's the principle of common good that needs to be applied, that no individual should be left behind. Every individual should have an equal opportunity, irrespective of their, socioeconomic status, irrespective of their religion, irrespective of their, geographical leaning. They should have the same opportunity as long as it fits into the metrics criteria of a business, to give out a loan or make a credit application or do some kind of a fraud detection. You need to exclude some of those things. The principles of common good need to be applied. It should be applied for all 100% of the people, not just 95% of the people, right? And which is why it has become such a huge concern in the boardrooms, in business leadership, saying that what if he gets slapped liabilities that are associated with my prediction, right? Now, of these 57% of the people really are worried about the new and changing regulations. Now, regulations in the form of some of them are guidelines, some of them are formal acts, and across the globe, you're finding these regulations coming into being. And so it's a very, very, lots of moving parts right now. It's not stabilized. And so the leaders or the innovators of AI in large business organizations, almost 50% of them are worried about, what's going to be the regulation that will hamper the investments that we have done, right? Another 62% of these, people, they want AI to be heavily regulated, right? There are lots of activism in this space, okay? There's lots of thought leaders in this space who are essentially saying that AI needs to be regulated because it can do climate harm, it can do human beings and harm, it could bring about social injustice, and all forms of disparity may come into being. So there are two sides of the debate that's happening in the world, right? Now, if I distill it down to principles of common good, let me give you a couple of examples, right? In a diverse perspective or in a cross-cultural perspective, as we know, any AI prediction analysis that we do depends on data. And what is data is nothing but a digital footprint of the individual. It's a digital twin representation of the individual on which you are going to make a go no-go decision. You're going to make a true positive or true negative or a false positive, false negative. This is a decision based on the algorithms. And so the data becomes absolutely critical to the success of the prediction that you make. Now, there was a World Economic Forum study in 2018. Now, in the Western world, an individual generates a data point once every 6 seconds. Okay, there is so much of digital engagement that happens in the Western world that at every 6 seconds an individual is leaving a digital footprint. Whereas if you go into other parts of the world, for example, Mozambique, where 90% of the people don't even have internet access, so they are not leaving any data footprint at all, right? Even if you go into our tribal areas in India, or you go deep into the villages, people. We say 90% of people may be using, phones today, right? But there are people out there, if you go into the deep villages of Karnataka, etc., who don't have, leave digital footprint. Now, if they were to embark on their, in the journey in their life for, let's say, seeking out a loan, a poor woman wants to, take a credit, there are no credit history, so how do you then associate a loan giving or a credit, lending decision based on somebody who does not have a input? Now, you can use all kinds of alternate data today to make an assessment, but as long as the alternate data doesn't look into the psychographic characteristics of the individual, the socioeconomic status of the individual, it is going to become very difficult for you to make a decision, right? So digital data footprint is one piece of it. Now, even in the Western world, if you look at it, there was a very interesting paper that's kind of published in Economist magazine. It says, in the investment banking world, the equity research analysts that rate these stocks, the buy, sell, hold rating that they give to the stocks, there was an inherent bias. If these individuals, if these analysts belong to a particular geography in Europe, for example, they rated the stocks of those companies in their country higher than others. So you have this aspect of it, right? So it becomes very important that, to remove any biases in your prediction, in your decision making, etc. How do you ensure, right from the person who's actually, engineering the data, scrubbing the data, wrangling the data, to creating features from that data, doing feature engineering, to looking at modeling the problem, what's the key metrics that we need to turn to make the prediction. In the entire life cycle of AI, we need to look at diversity. We need to bring in elements of social sciences into the discussion, right? And so how do we do that, right? Now, these ethical issues, as I mentioned, could be addressed at the organizational level. It could be addressed at the data level, and it could also be addressed in the algorithm level. Now, let me give you a couple of technical solutions, if you will, and how do you really take out bias from your algorithmic decision making, right? So one of the things we have talked about, people talk about AI explainability, etc., right? So AI decision making or prediction tries to predict based on the generalization that exists in the data set, right? So when we make a particular prediction, you need to look at the data, the statistical correlation that existed in the data that led you to making a decision. Does that statistical correlation have a leaning? Are you considering certain features, or are you considering certain data sets that is, leading to making the decision? So you can, with a tooth comb, literally, you can go into looking at the different features, etc., that are driving that decision making. Now, one thing you can do an A/B testing. You can remove some of those features in that data that remove some of those, some of those features that could actually drive bias into the decision making, and then see whether your algorithm is making the same prediction as before or not. And if it is not making the same prediction, then obviously you need to tweak your data sets. Now, it's very easier said than done, but what happens is, because historically all your data sets and all the decision making and all the labeling that you do for your prediction in your supervised learning, for example, it's based on many features that are actually inbuilt into the decision making. So when you remove some of those features which bring about bias in that, will your decision making would have been similar, historical decision making was similar, then you would need to get into creating some kind of augmented data sets to drive decision making or bring about labeling of the data which does not include that. The other thing we need to do is from the audit perspective, from the, every time you make a decision, a decision needs to be logged into an audit and compliance file. And what were the circumstances of making those decisions, right? What were the most, relevant variables or features that you used to make that decision? So almost like a blueprint of the decision making needs to be kind of captured into your audit file. The third thing you could do is, for every decision making, you would also bring about a kind of a confidence score, if you will, saying that this confidence score, if let's say it's 80% and doesn't include some of the biases that exist in the data sets for your decision making. So some of these things, could be used. The other thing is you could use to do, testing your prediction analysis if there is any biases in your algorithm is by using, what medical fraternity uses called placebos. So you can introduce elements into your data sets which will will lead to wrong decision making as a human being. But let's see what your algorithm, what your prediction does for you, right? So you need to look at these aspects in data, as well as when you're actually modeling the problem, and then when you're logging the output of the prediction in a audit and compliance file for AI purposes. The other thing, the change management across the organization, whether it's the data scientist, as I talked about, or the data manager, or the business people, you need to bring about diversity of thought into the decision making. It's no more, I have 500 different attributes to make a decision, and so let me leverage it all. You need to bring in the social science lens into the whole thing to be able to, obviate your biases into the decision making itself, right? So having talked about, why is this relevant? What are some of the, techniques that you can employ to make this decisions, right? Now, to the last part of my presentation is to what are some of the things that you can do as a framework when you think about holistically your ethical framework or driving your AI workloads. This is a framework that is we have put together as a 6-part framework. It's available on the website. You can look at it. It essentially looks at these 6 pillars, right? It looks at, how fair and how reasonable is the decision making, right? Does the AI application include internal and external checks to bring about, to reduce disparity in decision making and prediction, right? Across all participants, not just one. So principles of common good rather than principles of utilitarian needs to be thought through, right? Obviously, it needs to be robust and reliable. It should have the ability to include human beings into the prediction analysis. So we talk about human with AI. It's not just once you create an algorithm and you put it as an inference workload, it starts to make decisions for you. You need to have human beings into the picture because there will be model drifts that will occur. Your data will change. New kinds of socioeconomic biases will start to see. So you need to have checks and balances to be able to in your AI initiatives to bring about that robust and reliability into the decision making. Of course, we talk about privacy is a very important thing, and we talk about PII information, which is private and confidential information. We talks about healthcare privacy information. All those need to be factored in as well. And sometimes we use the concept of data digital twin, where we create a statistical correlation of the original data to where privacy is an automated outcome of the data digital generation. And then without losing the statistical correlation that exists in the original data, we can now create this data, synthetic data, which then you can drive. So privacy is a natural outcome of it. But you also do privacy by tokenizing of the data sets, etc., to make sure that you preclude all of those information. You bring in differential privacy concepts, to drive some of those, AI decision making that you do. It obviously needs to be safe and secure. You need to make sure that nobody should be able to infiltrate your data sets. And there are enough examples out there where even if you hide the privacy information, you have 6 or 7 data points on an individual, and you can actually re-engineer you can pinpoint the data back to an individual. So there are cases like that has happened. So you need to make sure that it's cyber protected. Your data sets are checked and on a regular basis for any fraud and then intrusion, etc., into your data sets that are driving some of these algorithms, right? It obviously, as a business leader, you want to make sure that your trustworthy framework has accountability, right? Where if you work backwards on the decision making, where do you think who's responsible for making sure that the output is not biased? Output leads to equitable decision making, right? So there needs to be checks and balances and be able for you to kind of have an audit trail back into the system, right? And of course, today, as you embark on explaining to a business leader that this AI prediction algorithm will reduce, fraud by 100 million or will lead to a customer acquisition by 10%, right? You need to demonstrate to the business leaders why do we believe that is the decision that is, likely to happen because of the information that we're looking at. Now, when we get into the deep learning networks, etc., it becomes very difficult because the feature engineering or the feature vectors that you have, it's very difficult to pinpoint, the reason for you to make a certain decision. So you cannot, as easily do that as you would, do it in kind of ML algorithm. So these are, some of the considerations that you should, kind of factor in when you are thinking about, trustworthy framework. So, I wanted to leave, a few minutes here for any question and answers in this brisk 30-minute session. I will pause here and love to hear your thoughts and your any questions that you might have on this particular topic. Divya, if there are no further questions, I can hand it back to you. Sorry.
Any questions? Okay. I have two questions. I have two questions to you. On this framework, whatever is the open source available or it is customized to your system? How is it?
Your voice is echoing, Divya. I cannot hear you properly.
Is it open source available or it is in-house?
I gather that you're asking a question about trustworthy AI framework.
Framework, yeah, it's open source or in-house.
Yeah, this framework is available on our website, so it's easily accessible, on our Deloitte website. So you should be able to, see, and also the state of the AI for the enterprise, the study from which I quoted, what are the AI leaders concerned about, across the 6,000 companies. That state of AI for the enterprise study is also on the website. So anybody who wants to take a look at it can take a look at it.
Okay. Thank you. I'll extend thanks to Amati for excellent presentation, and it was a pleasure listening to your presentation itself, and you have shared lots of facts, framework, data, people, and also the framework which we discussed. Thank you very much. And
thank you so much.
Yeah, we have organizing committee, the Bangalore Technology Conclave committee, and the Bangalore section, and we'll offer you the virtual momentum.
Thank you.
Thank you for your time. Thank you for joining.
Divya madam, your voice is people. Can you come closer to the microphone?
Yeah. Now, is it better?
Yeah, it is better now.
Okay. On behalf of IEEE Bangalore section and Bangalore Technology Conclave organizing committee, we present virtual memento to Mr. Amardeep. Thank you very much for your time and this presentation.
Thank you so much for inviting me. It was absolutely a pleasure to talk very briskly about the vast topic in 20 minutes, but hopefully the message got through. Thank you so much.
No, we will catch you again over offline.
Thank you.
Now we'll move on to the next presentation. The next presentation title is AI Use Cases from Indian Organization. The speaker is Dinesh Kumar, Professor of Decision Science, IIM Bangalore. He has published more than 30 case studies on business analysis and machine learning algorithms. I am Professor Dinesh Kumar, and now we have the presenter, and I find out the way I can do it. And it is one hour session, and let us listen to the various use cases from the Dinesh.
Hi, good evening. Thank you, Dr. Divya. So let me share my presentation. So is it visible now? Okay. So I guess my audio is fine. Okay. Good evening, all. Welcome to this session. And I would like to thank IEEE Bangalore chapter for inviting me to share what we have done at IIM Bangalore in the domain of AI, machine learning, analytics, whatever one may like to call. So I'm going to talk about few use cases, but before I reach there, we need to understand, even though there's a lot of buzz that we see today, this is not new.
Professor Dinesh, 1 second. You have to remove a window which is showing in your just before slide. It is
okay. I'll just 1 minute. I'll get rid of that. Okay, is it fine now?
Yes.
Okay. I'll just push it somewhere. All right. So what I was saying was that this is not new, right? Whatever we are seeing today, probably technology enabled us to achieve what many organizations have achieved through AI and machine learning and so on. But the power of AI, what we call it as AI today, or if you want to call it analytical thinking, has been known for at least 200 years. And organizations have used analytics to a large extent. Some of at least few organizations have used successfully even 100 years back. So this quote by Edward Deming basically says, "In God we trust, all others must bring data." Now, if you look at the earlier part of analytics, the way in which it was used by organization is to assist in decision making, right? And if somebody comes up with a quote like this, there must be a reason something must have triggered Deming to say this. So just to make this interactive, can somebody take a guess why Deming may have said this? What may have triggered Deming to come up with this quote? In God we trust, all others must bring data. Any guess? Okay. Let me ask a follow-up question. How do organizations take decisions? So if you look at the standard operating procedure used by organization for taking decisions, many of you are working in leading organizations. So can somebody say what do organizations do whenever there is a problem which in which they have to take decisions? Anyone? Let us make this interactive rather than just I'm talking. Can somebody say how do organizations make decisions?
They leverage the data to make some decisions, as well as use their own gut feel sometimes, based on some of the data sets that they have in the privy.
Okay, great. What is the first thing done by organization when there is a problem? What do they do first? Let us say there is a problem that address, and that means they have to take a decision. What's the first thing usually done by many organizations? I don't want to generalize what I'm going to say, but what do most organizations do? First thing they do whenever there is a problem. Anyone? See, in my experience, again, as I said, I don't want to generalize this. Most organizations, the first thing they do is they form a committee, right? They catch hold of some bakras, and then they say, okay, we have a committee, and the committee will look into that, right? So now we have a committee. What do committee members do? What's the first thing done by the committee members? Any guess? I'm sure many of you are part of several committees. What do they do? The first thing they do is form a WhatsApp group, right? So now we have a committee, a WhatsApp group, and then probably they send messages which are not relevant to what decision that or the problem that they are supposed to solve. But then in committee meetings, typically people express their opinions about how to solve a problem, right? But there is this famous algorithm called HIPPO algorithm, which stands for highest paid person's opinion. And many times, this is a kind of algorithm which wins. So people just take decision using highest paid person's opinion, right? Or HIPPO algorithm. Again, nothing wrong with this, because if somebody is paid the highest in the organization, he or she must have done something good, or there must be some capability with that person to receive the highest pay check, right? But then if you use HIPPO algorithm, we will not know to what extent the decisions are going to be correct, right? So probably Edward Deming must have seen many organizations are taking decisions using HIPPO algorithm. Probably that's what triggered his quote, in God we trust, all others must bring data. So basically, he's saying that I trust your opinion if you are God, otherwise please show me the data, okay? Now, when we talk about analytics, AI, and machine learning, deep learning, I'm sure there will be a lot more statistical learning, a lot more things that will come in the future. But what are we talking about, right? What is this, okay? So let us try to understand with a simple example. So what you see here is Facebook relationship breakups, right? When people break up, they go to their Facebook and then announce to the world that they are single now, they are happy, they are in the market, and whether anybody else is in the market. So these are some of the questions they ask. All right. We see a pattern in breakups. For example, a lot of breakups happen in December. Okay, which is just we are around the corner now. Now, can somebody tell me why a lot of breakups happen in December? Any guess? Come on, there is no right answer or wrong answer, it's just opinion. So can somebody say why a lot of people break up in December? If we believe that this thing is true. Okay, everybody is just listening, I guess. So my own view is, okay, so Somebody saying no money to spend? Or is it a New Year resolution? So this year I'm going to live with a new person, right? Is it because of New Year resolution that we see a lot of breakups? So my own view is, if you look at from July to November, the breakups are at the lowest level, and then it starts increasing. And if you look at July to November, these are probably working couples, go to office, come back very tired, just eat and sleep. In December, there are a lot of holidays, right? Then they start talking to each other. And that's when the problem starts. As long as they're not talking to each other, the relationship is fine. But then the moment they start talking to each other, they may realize that they're living with the wrong person. Too much time together is a problem. Okay, there could be many other reasons. But why should any organization even look at this pattern? What is the use of this pattern? Is there any organization can get some insight, or is any business in this world going to get affected because of this pattern? Any guess? What may this behavior trigger? What kind of trigger mechanism this pattern may create? What is likely to happen if there are a lot of breakups that happen in December? Any guess? Let us make this interactive. So, especially, being online, so I don't know whether I'm talking to participants or I'm talking to my computer. So, what do you think will happen because of this? More cases for lawyers, okay? Anything else? See, analytics at one level is understanding the pattern that exists in the data and try to connect the dots to understand what that pattern means to various business, right? So this may trigger what is likely to happen. There will be more traffic to online dating sites, and lawyers and counselors will be happy. There will be a lot of demand for them. If somebody breaks up, at least one person has to get out of the house. So there will be a lot of demand for housing. Somebody has to set up the house. There will be a lot of demand for household items, right? And one company claimed that people change the brand of the beer they drink after breakup. There is nothing wrong with the beer. It's basically they don't want to remember anything from the past. So what you are seeing is that there is a pattern. This is a simple bar chart, not some complicated deep learning algorithm that we developed. But we are connecting the dots to understand what that pattern means. We are inferring what is likely to happen in many different businesses because of this particular pattern. But identifying a pattern in a very noisy data, like say telecom data or banking data, a lot of unstructured data which is generated from IoT devices and so on, it's very, very tricky. So that's why we ended up creating a lot algorithms to deal with complex, unstructured, and also nonlinear relationship that may exist among the data sets. So today, thanks to all these technologies, we are at least able to analyze these data sets. Okay. So for example, somebody today sent me this. After the IPL started, the number of COVID positive cases has come down, or there is a decline. Obviously, this is a spurious relationship. It's nothing to do with IPL. So when we create these patterns, we need to also understand whether it's a cause and effect relationship or a spurious relationship that we are seeing through all these models, right? So let us try to understand why AI. I'm sure that many speakers would have spoken about this, but this is my view of why we need AI and why we need analytics. From a business perspective, large corporates would like to understand the economic drivers of the business. Now, they know the economic drivers of the business, but what are the factors that affect the economic drivers of the business? So that is a very, very important thing for them. Now, what AI has done is, AI has allowed us to manage mathematically intractable problems. So what do I mean by that? For example, let us take traveling salesman problem, right? Mathematically intractable problem. And if you take 20 cities traveling salesman problem, and if you want to exhaustively enumerate, and if you have a computer which can evaluate 1 million records per second or 1 million routes per second, it will take 77,000 years. We are talking about just 20 cities, right? VLSI fabrication is probably 1.2 lakh cities or something like that. If you look at Amazon, look at the delivery they make on a daily basis, how many traveling salesman problems they have to solve. How do you even solve these problems? So what AI has done is traditionally mathematically intractable problems for which we don't have efficient algorithms, it allows us to handle that, right? And for many of them, it has become a competitive strategy to compete in the market. So if you look at organizations, the way in which they use AI, there are two major strategies. One is transformative approach. These are AI first companies like Sundar Pichai's, he made this comment as AI first company and so on. So basically these organizations look every problem and every opportunity through the lens of AI. Now for that to do, the organizations should have rich digital assets. So they should have gone through digital transformation. But obviously if you look at big technology companies like Google, Amazons and Apples and so on, they're already digital companies. So they will find it easy to become AI first company. But there are a large number of traditional companies, it's not easy for them to become AI first company. They cannot look at all the problems through the lens of AI. We have not reached that stage. So they will use more like an incremental approach where you augment human capabilities using AI. And the kind of problem that gets solved, if you look at the macro level, people use AI for robotic process automation. There are a lot of manual work which gets done, and there are a lot of inefficiencies that exist because of that. You can process the entire automation through AI. The next is you try to gain cognitive insights about consumer behavior through data analysis. I'm talking more from a business perspective. And today you have a lot of intelligent agents. That becomes the third major application of AI, where you create cognitive engagement through intelligent agents like Alexa and Siri and so on with your customers. So this is how I see that AI is getting set up across many different organizations. Now let us come to the use cases that I am going to discuss. So when we look at analytics or AI projects, it has three components. One is your business or social context. So that allows you to take the right question or ask the right question or identify right project, because there are a large number of projects fail if projects are failed. One famous one is Anderson Cancer Research Institute. They wanted to use AI to recommend the most appropriate treatment for cancer. And after spending about $60 million, they realized that they can't do it, so they stopped it. So you need to understand well, and you need to select projects which can be solved using AI. And you need to have the right technology to support that. And then finally, the science, which is the data science, which enables you to mathematically analyze the problem and come up with a deployable solution which is scalable and cost-effective and so on. Okay. So now let me go through the cases. The first case, okay, before I get into the case, any questions so far?
No questions.
Okay. So the first case I'm going to talk about is, this is one of the cases that we did for Big Basket. Probably many of you are buying products from Big Basket. If you look at general online grocery store, or in general any grocery purchase, we have the tendency to forget. Whenever you visited a grocery store, I know today probably not many are going to grocery stores or kirana stores, but before March, I'm sure many of you visited some supermarket to buy grocery items, and you would have forgotten one or two items, right? So it is a very, very common problem. Now, what happens is that whenever somebody forgets in an online grocery purchase, and say they remember after half a day or one day, in this case, they may come back to the portal and then place another order. Or they may go to a nearby store to buy that, and since the customers are already in the store, they may buy products which they need in the future. So what happens is, there is this forgetfulness behavior among the customers, and that affects both the revenue. It brings down the revenue or increases the cost because they are making 2 trips. So it is a very, very important problem which online grocery stores need to address. Okay. If you look at Big Basket, just to give you an idea, this is slightly older data. They were selling more than 18,000 products or 18,000 SKUs and over 1,000 brands, right? At that time, they were operating in 24 cities. Now it may be more. And they used to handle more than 250,000 orders in a week. Again, this could be a lot more than this. And they have more than 4 million registered users, right? So if you look at this problem and the impact, 250,000 orders per week. One statistic says 30% of us forget at least 1 or 2 items. That means 84,000 are forgetting. Even if you assume the revenue for that forgotten item is 100 rupees, on an annual basis, this accounts for 45 crores. Okay? So 45 crores is short of revenues you're looking at because the customers have the tendency to forget. Now the question is, can I create a solution through AI to manage this problem, right? So that means, can I predict what the customer may have forgotten? Okay. So if you are a customer of Big Basket, after you add items to the cart, you see this, they ask a question, did you forget? Okay. If you can predict, it can have a significant impact for your revenue. Now the question is, how do you predict this, right? It is a modified version of recommender systems. Recommender systems can be solved using collaborative filtering or many other techniques that exist today. But then you will find a lot of data challenges, right? For example, many of these products will have promotion that exists only for a certain period, right? So you cannot ask that SKU and say, did you forget this? And many of the items, especially vegetables and fruits, are seasonal products. For example, let us say mango, typically available between, say, probably from Feb end to September, right? And your data has captured the individual customer transaction. It may observe that this customer frequently buys mango, right? And after some time, let us say the customer comes and adds the item to the cart, and your algorithm says probably the customer has forgotten to add mango. And let us say you ask the question to the customer, did you forget mango? And obviously the customer will be delighted and he will say, yes, I forgot, and he checks. But then it is December. You don't have mango, right? And you realize that you also don't have mango in your warehouse. So now you cannot send a pop-up message to customer saying that, sorry, we also forgot to buy mango. It doesn't work, okay? So the way in which you pre-process the data, which is true for any ML, AI, analytics algorithm, unless you identify the right feature, engineer the right feature, it may not be a successful AI project at the end of the day, right? So in this case, you get into a lot of these issues related to the data, at what level, and so on. For example, you don't want to ask the question, did you forget 200 ml Coke bottle, right? Because if you go and look at that level, then the number of cases you're looking at will be thousands. Either you say that, did you forget a soft drink, rather than asking, did you forget Tetra Pak 200 ml Coke or something like that, right? It doesn't make sense. So you get into a lot of these data challenges, right? And you have to deploy a solution in real time. That means there is a difference between theory of practice and theory of art. So we have the tendency to look for algorithms that give us the most accurate answer. But that may not actually serve the purpose. For example, if my most accurate algorithm is slow, it doesn't serve the purpose because I cannot deploy in real time. What I mean by that, suppose let us say the customer has added items and then he or she is about to check out. I cannot send a pop-up message saying that wait for 5 minutes, we are trying to figure out whether you forgot something or not. Doesn't work like that. And then if you are recommending some items to the customer, ensure that you have those items in your warehouse. Otherwise, it doesn't make sense. Okay. And also, you have to ensure that you are able to predict accurately the items forgotten by the customer. Okay. So what we did, there are many strategies. Obviously, we can use the traditional recommender systems such as collaborative filtering and so on, but we use reinforcement learning algorithm. And this is basically modified version of Google's page ranking algorithm, where you create different baskets purchased by the customer in the past, which are basically different transactions, and try to figure out how individual items within those baskets are related, and convert this relationship into a Markov chain. And once you have the Markov chain, you can, so this is, I'll not get into the math, but I'm just writing this similar to what Google did for their page ranking algorithm, right? And we solve the page ranking, using page ranking algorithm, we create a rank of items even before the customer logs into the portal. And as and when he adds items to the cart, this rank gets revised. And once he or she is about to check out, these items pop up, right? And it's a complex page ranking algorithm that we are trying to solve to rank items for individual customers, right? And you, in the real time, whenever the customer starts adding the items, you create your recommendation in real time and then ask this question. So if you look at many of these things, at the end of the day, you have to look at what is the financial impact, right? Many organizations have inertia because if they want to bring in AI, they have to go through change management. That's not easy to do in many organizations. So unless you show the impact, it may not fly. So this is one project, I think, which benefits a lot, Big Basket, and it is a very, very innovative idea that they created, right? So what I'm trying to say is that your AI should be innovative. It's not that hobby project. Many organizations have something called hobby projects, right? They basically keep doing projects without, it is not aligned to the strategy of the organization. It may not have any impact for any of the KPIs of the organization, so on. So it's very, very important that you select a project which has some organizational impact, okay? The second case I'm going to talk about is on Akshay Patra. The first case is on a commercial enterprise, e-commerce, commercial enterprise. But we should not think that AI is only for big companies, right? A lot of SMEs can benefit a lot through AI and analytics and so on. So I'm going to talk about Akshay Patra. Probably most of you know about Akshay Patra. They provide free meals to underprivileged children studying in schools. These are mostly rural area schools. Just to give you some idea, we were doing this in 2014-15. At that time, they were serving 1.4 million children across India, and they had a target of reaching 5 million meals by 2020. Okay. When we were doing this project in Bangalore alone, they were serving 1.85 lakh meals. Now, you may think that, okay, if they are giving free meal, what is the big deal, right? What kind of problems they face? Now, they have a lot of KPIs that they have to meet, okay? This is a public-private partnership. 60% of the resource is given by the government. They provide rice, wheat, dal, and so on through Food Corporation of India. And the remaining 40% is through donors. So there are a lot of corporate donors. There are a lot of individual donors. That's how they manage. And at the time, the budget for each meal is about 7 rupees 50 paise. Okay? So it's a highly sophisticated kitchen. I don't know how many of you have visited any of these Akshay Patra kitchen. It's usually a 3-story building, and each kitchen can prepare a meal for about 1.5 lakh children, right? And we looked at one of the kitchen, which is in the Vasantapura Hill, in the Kanakpura Road in Bangalore. And in 2014, they were serving about 650 schools and about 87,000 meals every day, right? And the furthest school was 4 hours from the kitchen. And they were using 35 delivery vehicles to serve these 650 schools. All right. Now, what are the different issues they face? The first thing is that as per their contract, they're supposed to deliver freshly made food. Now, the question is, what is the definition of this freshly made food? If it is a freshly prepared food, that means the cooking to consumption time should be less than 6 hours. Okay. Now, what that means is you cannot cook the meal the previous night and send it to the schools. It violates the KPI. So it should be prepared such that the cooking to consumption time cannot exceed 6 hours. And most of the schools, the lunch time is 12 o'clock. That means you cannot complete the cooking before 6 o'clock that morning, right? And the temperature at the time of delivery should be 65 degrees Fahrenheit. Sorry, 65 degrees centigrade. Okay? And much critical thing is, since it was a public-private partnership and there are some contracts signed, and one of them is nutritional value of the meal. That means the calories, lipids, protein, energy, and so on. You have to maintain them. Now, how difficult it is, right? If you look at the nutrition value of the meal, in South, they basically provide rice, sambar, and yogurt rice, and sometimes with the curry and so on, right? Now, what happens is the fluctuation in the price is huge among vegetables, right? For example, one day onion could be 20 rupees and suddenly it can become, 120 rupees. Potato can go from 30 rupees to 90 rupees, right? You see huge fluctuation in the price. And you have a very, very stringent budget, which is 7 rupees 50 paise from me. How do you deal with that, right? How are you going to handle the heavy price fluctuation happens in Indian market, especially among vegetables? One option is you can substitute a vegetable with something else. But that's not easy in this context, right? So for example, let us say the potato price has increased. It used to be 30 rupees, now it has become 70 rupees. Now what you do, instead of potato, let us say you put soya bean, right? In sambar. The taste of the sambar will be different. So once they tried that, and they got into some unexpected problem. Because many rural children they have not seen a soya bean. Okay, even the parents have not seen soya bean. So they thought it is chicken, because if you look at the texture of soya bean, it has a texture of non-vegetarian, right? So the children thought that they put chicken in sambar. And then they started complaining, saying that we are vegetarians and so on. And even the parents started complaining, how can you give chicken sambar to our children, right? So you don't know where these problems are going to come. Okay, how do you manage this entire problem associated with the price fluctuation when you have very, very shoestring budget of 7 rupees 50 paise for each meal? That's not only that. Given the traffic conditions in Bangalore, on a daily basis, how do you ensure that your food reaches to the school before 12 o'clock, right? If you look at Amazon, same problem. It's a traveling salesman problem that we are talking about. So the problem that Akshay Patra deals with is also a traveling salesman problem. And what Amazon deals with is also a traveling salesman problem, right? But there, if they delay it by one day, obviously the customer will be unhappy, but nothing is going to happen. Here, if there is a delay, there are some 500 children, hungry children waiting at the school for food to arrive. So it is a lot more critical here, right? And here also they are solving traveling salesman problem. And top of that, Amazon may not worry about the cost of operation because of the deep pockets they have. So here they don't have deep pockets, right? Every 1 rupee increase is going to be very tough for them to manage. So all these problems are actually managed through Six Sigma kind of project, through a lot of innovative ideas to solve many of these problems they encounter, to make this entire providing free meal efficiently, effectively to schools. And remember, when you add one school, it is not just you're adding, you can't look at just one school getting added. It may be some 500, 600 children. That means adding one school will increase the number of meals by another 500 or 600. And how do you maintain all these KPIs and ensure that you meet all the regulatory requirements and also keep the school children as well as the schools happy? Okay. So I talked about a commercial enterprise. I talked about the NGO. You can consider as a small and medium enterprise. Now I'm going to talk about large-scale complex analytics, which are usually comes in the form of prescriptive analytics, right? So let us look at this. The skies may be different than this, but hopefully after COVID, it may come back to this maybe in 2 years down the line. So if you look at the skies, the airline operations are very, very complex, okay? Every airline has to solve a lot of prescriptive analytics problem. For example, scheduling, right? You have to come up with optimal schedule given the connecting flights, given the sector demand between, say, India, New Delhi, Bangalore, or Bangalore, New York, Bangalore, London, Frankfurt, all those kind of things. Then you do fleet assignment. So which aircraft model should perform? And then you have maintenance optimization and so on. There is an interesting problem in this called tail assignment. Every aircraft you see in this map is uniquely identified through a number which is in its tail. So let us say there is a flight from here to Delhi, right? Now, through fleet assignment, you may decide, okay, that will be done by Boeing 737, let us say. But then an airline will have, say, 20 Boeing 737 aircrafts in their fleet. Now you have to specifically identify which one among the 20 will do that particular flight. Okay? What is the big deal? You are looking at a network. Your network has the origin destination across the globe. And there is a ground time that you have to maintain, minimum ground time, depending on whether it is domestic or international and type of aircraft and so on. Okay? And then you have a maintenance schedule. So you have a overnight maintenance, weekly maintenance, A check, B check, and so on. For example, let us look at weekly maintenance. The weekly maintenance cannot be done in all airports because they'll have a designated hub airport. Each airline, they will do that. They can't distribute their resource across all airports in the world. For example, British Airways flies to 250 airports. They cannot have their resource in all 250 airports, right? So that means that aircraft or all their aircraft should return their hub airport once in every week. If you don't do that, then your aircraft is not airworthy. It has to be removed from the fleet plan. Okay? When it goes for weekly maintenance, that aircraft is not available for 4 to 6 hours. And that's, so now there are a lot of flights, maybe 1,000 flights, 2,000 flights on a weekly basis. You have to manage this. And suddenly you'll have a, airport related constraints. Say the runway is quite small, so you cannot land certain aircraft types in certain airports, right? And they will have other constraints. So for example, when we were solving this problem for one of the Gulf-based airlines, they said that there are aircrafts which come from Africa, let us say Kenya, right? And they carry a lot of flowers which gets sold in London the next day. So there is a cargo which is coming in addition to the passengers. Now taking that cargo and putting in another aircraft is time consuming. So they said that, okay, same aircraft should be, sent to London. So you'll have so many such constraints coming. So let us look at a simple scenario. So this is basically origin destination, and you have expected time of departure, expected time of arrival, ground time, and so on. Even when you have just one or two aircraft, it becomes a very complex time-space network. So let me tell you how complex it gets. So we looked at a fleet of 9 Boeing 777 aircraft, and the number of flights was 542. Okay? And the number of variables was 60,000 and constraints was 45,000. It just increased by one aircraft. So from 60,000 variables, it went up to 227,000 variables. Just increase of one aircraft, and obviously the number of flights increased to 910, and the number of constraints increased to 196,000. Okay. If you look at a mid-size airline, they'll have about 150 aircrafts. The large airlines will have anywhere between 500 to 1,000 aircrafts. If you don't optimize such kind of problems, you have very high probability of going bankrupt, because airlines work with very, very thin margin. If they don't optimize the entire operation, there is a high probability that you will go bankrupt. So once somebody said that if you want to become a millionaire, start with a billionaire and start an airline, you'll become a millionaire, right? So most of this is because this is very, very complex problem that you need to deal with. And this is, if you don't do it, you are at the risk of going bankrupt, especially in airline business, right? So what I looked at is, I have a lot more cases, but for want of time, I'll just close here. Probably we can have a discussion. But if you look at on all these cases, what makes an AI project successful project? Obviously, you need a quality of talent, right? There are a lot of people who get trained, but more in Python or programming rather than understanding the business, trying to understand what should be the right question and so on. The next is quality of data, which plays a very, very important role, because in most cases, you have a lot of noise in the data, and it gets lost in removing that noise from the data itself, right? Quality of data is a major impediment today. You need obviously the top management support, and you cannot just go and do a hobby projects. Right? What do I mean by that? Everybody else is doing, so let us do it. You have to drive innovation through analytics in the organization. Only then you're going to see benefit out of analytics. And then it has to be aligned. Whatever you do through AI has to be aligned towards your organization strategy, right? The reasons for failure is my competitor is doing, let me also do. And then impatience. You don't expect, it's not like you start a project tomorrow, you're going to get benefit out of that. Okay? And many times people don't understand the lack of limitations of AI. So they think that you have a hammer and you can hit every nail with that hammer. It doesn't work like that, right? And many times it fails because of lack of support. Again, I can say, relate that to the impatience at the top management support, right? So my final thought is, in the future, you will see lot of innovation that happens through AI or analytics. And post-COVID, people will realize that so till this time, there are a lot of industries where you can be inefficient because the entire industry is inefficient. But now you realize that you cannot be inefficient and survive in the market. Okay? But one thing which overrules all this is importance of the reliable data. So many times analytics projects fail because they use data which is very poor quality, or sometimes people don't even realize that the data that they're using is actually manipulated data, right? For example, let me tell you a case, and with that, I'll close my talk, and then if you have any questions, I can answer to those. So there was an online poll in 2000. This was done in in UK. And the question was, who is the most influential man of past 2000 years, right? And this guy was voted as the most influential man of past 2000 years. I don't know how many of you can recognize this person. Let me give more details about this online code. I'm sure you can recognize him. He came second. He lost the election. And Karl Marx came third. His name is Jamie Pollock. He won the largest number of votes. Right? He was a midfield player for the football club Manchester City. In those days, Manchester City was in Division 1. And this was the penultimate match of season 99-2000. And Manchester City had to win, otherwise they'll be relegated. The Queen's Park Rangers, who was the opponent of Manchester City in that match, they were also more or less in the same position. This is what happened in the match. Now the ball is with, that is the player, right? He puts a very good goal. But the problem was, this was the wrong side. So with all that, Jamie Pollock scored a self-goal. And because of that, the match ended in a 2-all draw. And Manchester City was relegated to Division 2, and Queen's Park Rangers stayed in Division 1. Right? And this poll was immediately after this match. All the fans of Queen's Park Rangers went and voted for Jamie Pollock. So what I'm saying is there are a lot of biases, there are a lot of manipulations happen in the data. We need to be aware of that before we take this journey. Ensure that the data is reliable before we go and build models and start taking decisions and drive features, technologies, and many other things which one can do through AI. Right. So with that, I'll stop my talk. If you have questions, please go ahead. I'll try to answer. Okay, so the questions keep disappearing. So let me. So it pops up, but then it disappears. So let me. Just give me a second. Okay, so I'm just in chat. Let me look at. I opened the chat box. So why create different baskets for the same user and not one basket? Now, see, the baskets are basically different purchases that they made over a period of time. Okay, and what do I mean by that? They would have purchased 25 times. So you will have to start with in your training data 25 different baskets. Okay, the way in which they buy products may be related to what other products are in the basket. You would have heard this famous story of baby napkin and beer, the association, right? So I cannot have just one basket. And also, the consumption pattern will be different. For example, let us say a customer purchases 5 kilos of rice. And if it is a small family, and if they're not rice eater, they are wheat eaters, that 5 kilo of rice may last for 2 months. In some other family, 5 kilo may not even last for 1 week, if they're a large family and mostly rice eaters. So you have to bring in all these things when you make this prediction. Okay, that's why you maintain those things. Okay, the next is what is the role of AI as some of the use cases you have mentioned, such as airlines, are of optimization use cases. Okay, now the first one, if you look at, okay, you need to understand AI, the way in which we use AI, right? There are, ultimately, if you look at the AI, it's basically the machines that exhibit human-like intelligence, right? That means we have to make machines think like human. That means they take decision. So my first case, the big basket, is not optimization. It is a predictive analytics, right? It uses machine learning algorithm, and machine learning is a subset of AI. The second is more like a Six Sigma kind of projects. And there also, to some extent, there are a lot of predictive analytics algorithms used, predicting what will be the price of, potato next month or onion next month and so on. So we have done a lot of other projects. Most of these projects are published as case studies at Harvard Business Publishing. So all the three cases that I'm talking about, they are cases at the Harvard Business School. I can tell you an interesting case that we wrote on Eureka Forbes. So the Eureka Forbes, if you look at, one of their important product is water purifiers. And whenever you need a product, whenever you want product, what you do, you either go to some website and then look at the different products that they are selling and try to understand the feature, price, and so on. So their website gets about 7 lakh hits every month, right? Out of 7 lakh people who visit their website, only 3,000 buy. So that basically means that 4 out of 1,000 people are buying the products, those who visit. Now the thing is, can you pinpoint which 4 will buy? Right? This is using, you can solve this using machine learning algorithms such as random forest boosting and so on, or you can use deep learning networks to predict that. So those are the cases that we have looked at, which you can call pure AI and so on. Okay. Okay. How is the scope of approximate dynamic programming in the TSP? See, obviously the approximate dynamic programming gives a lot more power, lot more quicker compared to other algorithms. But then TSP in general, the moment it starts increasing the cities, it's not that easy. But yes, approximate dynamic programming is probably slightly better than some of the other algorithms. But people may sometimes prefer genetic algorithm or some of the meta-heuristics algorithms. What is the economics of adoption of AI? What I mean is that in India, already availability of cheap labor often acts as an impediment. Sorry, 1 minute. I don't know where it disappeared. Okay. See, AI is nothing to do with whether the labor is cheap or not. AI is make the system efficient. So, for example, we did a project to predict the crop disease. So many times there is a statistics which basically claims that India loses anywhere between 35 to 50% of its agricultural produce because of crop disease, right? Now what is happening is that the farmer may not be able to rightly identify what is the disease. So we collected data on tomato plants, the leaves and stems whenever it gets affected by a disease. So depending on the disease, you can see some changes that happen in the leaf of tomato plant or stem of the tomato plant. So we collected a large number of images and developed a deep learning algorithm to predict what is the disease and what the farmer should do. And we also did this for grapes, right? So it has nothing to do with the cheap labor or uncheap labor and all that. It is about making the overall system efficient, right? There is this fear that AI may replace jobs. It's not going to replace jobs. That you will need reskilling, right? So that's what is happening. So you have to reskill people in a different skill that will be required. Now, whether we like it or not, so see, if you go back to 80s, when the computers came to India, right? This was the same argument which people say, right? Computers will take away jobs. And one of my colleagues at IIM Calcutta told me that they sent few computers to one of the banks in Calcutta. This is in 80s, right? And bank employees took all the computers and broke them on the street, saying that, I don't know how far this is true, but this is a story I heard, right? And broke them, saying that will result in loss of job. Now, Calcutta never recovered from that incident, right? If you look at Bangalore became a huge IT hub. Chennai became a huge IT hub, right? Hyderabad became a huge IT hub. So people did not realize that it is going to create more jobs. It is not going to take away jobs, right? So if we are intelligent enough and smart enough, we can create more jobs through AI instead of worrying about some jobs which are likely to go, right? Yes, some jobs will go, but that will be low-skilled jobs. So there will be a lot more high-skilled jobs that will be created. Okay, so I think I answered to most of the questions. What do you see happening or being adopted in terms of AI by enterprise business in the near future? How would they evolve from where we are today? Okay, so as I said many times, people are going to innovate, drive innovation through AI. And that will be the main driver. Okay? And we are going to see a lot of futuristic problems that are getting solved. I work with a lot of companies where they struggle with fraud, right? In fact, I don't know how many of you read this news. This week in Mint, the Punjab National Bank, which is plagued with a lot of frauds, several thousand crores of fraud that happened, they are saying that we are going to use AI to stop fraud, right? So you will see major problem that the particular company faces. People will start looking for AI as a solution. And there was an article which was published in 2010 in MIT's Loan Management Review, which basically said that AI will be the main differentiator between high-performing company and low-performing company, right? So you will start seeing that high performers will adopt AI, and low performers, if they don't do that, then they'll disappear. You'll see a lot more companies going bankrupt after COVID-19 and a lot of mergers happening after COVID-19 and so on. And it is my opinion that people who got into AI first and digital transformation much earlier, they will survive. Okay? Right. I guess I answered all the questions. What is the role of AI as some of us use case? Okay. I think I've done all that.
Thank you.
There is one question, Professor Dinesh.
Okay.
There is a question from Krishna. He's asking, in Akshay Patra, is the transportation is the biggest problem. How is it going to be solved using the AI without addressing the local traffic issues?
Okay, so it's a dynamic traveling salesman problem is what you need to solve, right? So one of my colleagues, Professor Mahadevan, he actually created an algorithm. So remember, it is not a 500 city problem. Okay, it's a 20 city problem is what they are trying to solve. And yes, you are right. Given the traffic and roadblocks, suddenly somebody may cut off the road and all that. So that's why your real-time information also helps. So you can integrate your Google map along with your trip plan and so on. So you're not solving a static traveling salesman problem. You're solving a dynamic traveling salesman problem, right? And that helps them to manage it well. So it is very rare that they don't deliver by 12 noon. Okay, it's very rare that they fail to do that. Okay, and obviously, if it comes to that, then what will happen is that they have to increase their fleet size. That will increase the cost. So can you do it without increasing the cost, right? Or even come up with a strategy, decentralized kitchens and so on. So the case has multiple dimensions to it. So I spoke only about one small part of that. There is a question, availability of public data for training purposes could often impede innovation in new AI-based products and services. What is the government and the industry doing in this regard, right? So see, government has gov.data.gov.in, right? I mean, every government has. But the problem with this data is it's a macro level data. Macro level data is not going to help you to understand the problem in very accurate way. So unless you have a micro level data, you will not be able to do any innovation. Unfortunately, most of the publicly available data are macro level data. So I will not even look at it. So if a country or organization wants to take AI seriously, the first thing they have to do is put the data governance in place, right? And many organizations probably do not have data governance structure. That means what data to collect, where to collect from, how to store, how to retrieve, who should have permission to access the data, what kind of algorithms can be analyzed, how do you take care of the ethics issues. So the so-called data governance covers a whole lot of issues associated with AI. So the first thing the organization or country should do is put your data governance structure in place, and rest of the things will fall in place. Okay, I think I answered most of the questions. Okay.
Thank you, Dinesh.
Okay, so you can. I have given the email address. They can send me a mail. Okay.
Fine.
So all the best. Good night. Yeah.
Okay. Thank you.
Thank you.
Professor Dinesh Kumar for delivering interesting and very informative talk on various use cases in AI, very more than in Indian context rather we are trying. Now, on behalf of organizing committee, Bangalore Technology Conclave organizing committee and IEEE Bangalore section, we present a virtual memento as a application. Please have it.
Thank you. Thank you. Thanks. So I'll just log out now. So if any of the participants need more details, they can drop email to me. Okay? Thank you. Bye.
Yeah, this is your memento.
Yeah, we can go to the next. I think he has already dropped off.
Yes. Oh, yeah, nice. Our next, welcome to the speaker. Yeah, the next presentation title is When Will We Ban Human Drivers? The Challenges and Opportunities with It. The speaker is Professor Nov4. He is an IEEE Master Innovator, Artificial Intelligence subject matter expert, and Professor at University of California. And I welcome Nov4 to take on the dialogue and now we are presenting that. Welcome.
Thank you, everybody. I hope you're all having a wonderful day so far. Just give me a moment to share my screen. All right. I hope you can see my screen. If you can't, please do let me know.
Yes, we can hear you.
All right, perfect. I'm very honored and excited to be here. You've probably noticed the title, When Do We Ban Human Drivers? I will actually talk about that in a couple of slides, but it's actually the big question that we're debating in the United Nations right now. Probably not what most people expected to hear. But let me start off with dogs. So what happens when you bring a dog to a technology conference? Most people, it's a cute dog, right, golden Labrador, but there's actually something very special about this particular dog. So if you notice, it's actually, you see a little thing that says Guiding Eyes for the Blind. Guiding Eyes is a nonprofit that provides seeing eye dogs to people that are vision impaired. Now, they go through a lot of effort to look at puppies at a young age, figure out which ones might make good seeing eye dogs. That's a lot of time in training the dog, and then hopefully match it with a person and the two mesh and they get along. Their success rate is around 30%. So that's not too great. That's a lot of effort and a lot of people that need help. But you have less than a 1 out of 3 chance of successfully teaching the dog and then matching the dog to a person. So they actually came to us and said, can we do anything with artificial intelligence to help us? I'll be honest. I was like, I have no idea, right? We can explore it, but I don't know what we can do here. But it actually turns out there's a wealth of data in dog psychology. And tapping into that, we're actually able to train an AI system to analyze puppies as young as 7 days old and see, based on how they interact with other dogs, could they make a good seeing eye dog? Are they teachable? Or they actually learn these lessons well? And then working with human trainers, the AI helped develop personalized curriculum for each dog on how they would best learn. And then when the training was completed, at the end, the AI would actually do a psychographic profile of the dog. So it would actually analyze the dog across 56 personality traits. And then the people that were looking for a seeing eye dog, they would also get psychographically profiled, and the AI would do the matchmaking. Guiding Eyes went from 30% to 81% success rate. This is the power of AI. This is something that most people would have never realized. Like, you can actually pick dogs, train them, and match them with people like this? The answer is yes. There's a reason why we call AI the the third generation of computing. It brings a whole new set of capabilities that we're just scratching the surface and tapping into. So we always talk about AI as the digital assistants, the Alexas, the Siris, the Pixels, the Bixbys. They're far more than dancing robots and these digital assistants. The problem, though, is we're trained to think of computers as automation, doing something faster, cheaper, or less errors. That's okay. We can use AI for that, but we're only unlocking 20 to 30% of the value out of that. If we really want to unlock the full potential, we have to think about how we change the process, we change the system to find a new way of performing the work. And this is hard for us as people because it means we have to look at computers, look at machines differently than we've grown up with. But if we can do that, we can tap into a lot of potential. And to show you what I mean by unlocking this innovation, I'm going to play you a really brief video. It's embedded in the slide. There's not much audio, so don't worry too much about that. But watch what this gentleman is doing and watch what happens with that robotic arm. You can probably notice he's able to control that robotic arm, that hand, somehow with his mind, right? And we always think about like Elon Musk and his company Neuralink, where they actually want to put computer chips inside our brains, use AI to decode our brain waves so we can do things like this. Because we know the brain can still send a signal to a phantom limb, even if you were born without it or you lost it in an accident. Well, detecting brainwaves has a lot of variability, right? There's a lot of different things. It's very complex, and right now we're not very close on cracking that. The question is, how did this guy do this then? Well, smart engineers working with biologists and doctors realized that the brain sending that signal is a process, right? It sends a little ripple effect throughout our body, including the movement of muscles and tendons. And so if you look just above his right elbow, you'll see a little black band there. That's an IoT sensor array that's designed to pick up even little small nuanced muscle and tendon motion. Using AI for that, less variability, they've been able to decode what these muscle motions mean and then have the AI translate that motion into a robotic hand. That's how they're actually able to restore mobility for this gentleman. It's actually how he's able to do it. It's a radically different way of thinking about how to use a machine, to use a computer. So this is the challenge, but this is the opportunity that we have. So I thought I would start off by just sharing my magic formula, because some people are probably wondering, well, I want to do something like that. How do we actually do that? It's not problem solution. It actually starts the mindset. We kind of have to break our thinking of how computers work and open up ourselves to be kind of a little more entrepreneurial. Let's think about not just, well, it's never been done before, why you can't do that. Let's think about what we want to try and do and see if it's possible. You get in the right mindset, then we define the problem that we want. So in this case, we want to try and restore mobility to a person that's lost a limb. So we think about what's involved, and we bring the right domain expertise in. So we bring the doctors and the biologists that know how all these systems work. This creates our opportunity, or what I call the art of the possible. Once we have this, then we bring in the technical expertise. So we bring in the people that know about AI, machine learning, IoT sensors, data, and we see what's possible. And then we look at the infrastructure. Do I need high-speed internet? Do I need powerful computers? Right? Can I just get away with something on a tablet? So I think like the constraints that are going to exist. And that vets out an actual solution. So this is how these guys actually brought innovation to the table through my magic formula right here. And it's something that everyone can do. This is how people are really tapping into the power of AI. The other thing we have to remember is that machines think differently than we do. Very simple example, photographs, right? You put up an image, our human eyes are trained to look for objects, right? Machines actually don't look for objects, they look at pixels. So they look at colorization and some other things. So even though we're looking at the same image, we see it actually very differently. And so as a result, the way we get to our conclusions and the interpretation is actually different. And that's a good thing. So we want to tap into that different perspective the machines have to try and do things better. This is why we'll wind up banning human drivers. Self-driving cars, autonomous vehicles are a great example of why machines are actually better drivers than people. When you think about how we drive as humans, we rely a lot on our eyesight, our vision. And the first set of autonomous vehicles relied on camera data until one day there was a gentleman in his Tesla and he was busy watching a Harry Potter movie. I am not kidding. He was watching Harry Potter, but he had his car on autopilot, right? Nothing to worry about. Well, there was a truck that had wiped out on the highway, and the truck bed was obscuring the road. And even though you could see it from 300-400 meters away, the Tesla never stopped, right? It kept going and ran through the truck bed, ripping the top of the car completely off. Everyone started asking, like, why did this happen, right? Why didn't you see the truck bed? Well, the truck bed was white and it was a cloudy day. So from the camera's perspective, the truck bed blended into the background. So it never actually saw it. This got people to thinking is like, why are we just relying on camera data, right? Machines can understand radar. They can understand LiDAR, right? They can actually use auditory information. It's actually a well-known fact that you'll actually hear that little kid about to run across the street before you see the little kid run across the street. Then you toss in things like GPS, IoT sensors in the road and traffic lights and under cars, right? That autonomous vehicle knows exactly what's around that blind curve before it takes the blind curve. These vehicles are processing thousands of data points in real time every second. They can drive in a way that no human can, and the car is not going to get distracted. It's not going to worry about who's texting me. It's not going to worry about being tired, right? That's why actually machines can actually drive better than we can. This is why the conversation has gone from when do we think we'll have self-driving cars and when would it be okay to legalize to when do we actually ban human drivers? Because ultimately humans will produce the most variability in the system. And the UN has actually estimated that every year worldwide, 20 billion people either die or suffer horrific permanent injury. That number gets reduced 98% if we're using autonomous vehicles. 19.6 million lives changed forever, every year. That's why I say, when do we ban human drivers? But we have to remember that machines think differently, again, to take advantage of the technology. And we're all living in the COVID pandemic era. This is another example of where we could actually tap into AI. Combining this with generative design, the AI can actually generate millions upon millions of different design options. So we no longer worry about trying to give the machine requirements. We teach it about different things. So in terms of the virus, we would teach it about virus genomics and mutations, and then we'd ask the AI to actually model out possible mutations, new viruses that we've never seen before, and would actually do that, millions upon millions, would most likely put for human review. But by doing this, and if one of these should actually occur, we actually already have the virus genomics. We actually understand far more about the virus beforehand. We could actually, if we're really concerned and say there's a real probability this virus will exist, actually start the research and production of a vaccine. So by combining AI and generative design, we actually have the ability to prevent epidemics, let alone pandemics. Now, I know you're all saying, like, why didn't we do this before? That's the big question everyone's actually asking right now. It is a lot of time, a lot of effort, a lot of cost to set this up. But I think if we knew 5 years ago what we know today, I think we would probably have made the investment much earlier into this. But again, you can see it's a different way of thinking about how to use computers. Another example, and again, it's another example of AI generative design. This is Ollie. It is a self-driving, solar-powered, 3D printed bus completely designed by IBM Watson, an AI system. Right? We taught Watson about transportation and vehicles. We didn't say make it 3D printable. We didn't say make it solar powered. We just gave requirements. We said we want it to be energy efficient. We want it to be easy to construct, low cost. It has to be able to carry 12 people, right? And this is actually what it came up with. It's actually in use in various parts of the world, usually at conferences, ironically, but you hop on, it's self-driving. You can actually have a conversation with Watson while you're a passenger, but it's energy efficient. It is low cost. You don't have to worry about shipping anywhere because you can 3D print it. But again, when Watson did this, it generated millions upon millions of design options, narrowed it down to its top 7 choices, shared them with the human engineers who then did the kind of the final reviews and a little specking and decided on this was probably the best design option. So again, the power of AI, the power of innovative thinking. Now, I don't want to say it's all about commercialism. I do work with the United Nations, help them start AI for good, because we can use this technology first for social good or for social enterprise, right? Again, we talk about different generation of computing. We're also entering a different age when it comes to actually even things like business, where the Generation Z and the young millennials are very into working for companies that want to help society, help people, help the planet. And we're used to either thinking about making money or thinking about doing good, but we can actually do both at the same time. And that's no different with AI. So you might be surprised to learn the biggest illness in the world is actually loneliness. Before the pandemic started, about 40% of people worldwide suffered from moderate to severe loneliness. I'm sure that number is way, way higher today, unfortunately. That's why you have people tapping into areas like artificial empathy. So trying to have AI, even though they don't feel the emotions, can detect them in people, respond, dynamically change how they interact. And one great example of this is an initiative called Loving AI. It's probably not what you're immediately thinking of, but it's a project out of Nairobi, Kenya. And what they're trying to do is teach AI unconditional love. The goal is that people who are suffering from loneliness have an outlet, someone that they can engage in a safe space that's not going to judge them. It's not meant to be a substitute for human relationships, but help people build up their confidence, feel like they belong, so they can actually work towards building real human relationships. So it could be a very powerful thing. Now, they're trying to do this by teaching AI unconditional love. Well, how do you do that? Right? AI can only do what we teach it, and we can only teach it what we commoditize. So how do you define unconditional love? And how is that different than regular love? And what are the different types of love? The love between two spouses, parent and child, friends. So as they're actually doing this, and they're trying to help people with the biggest illness in the world, this has also turned into a very deep exploration of what it means to be human. Ironically, AI is giving us a chance to be more human than we already were, to get more in touch with ourselves. So it's a very powerful social good story right here. Another one, and one of my favorites, is something called SnotBot. So snot is a colloquialism for mucus. I kid you not, this is really called SnotBot. And what this does is it combines drone technology with artificial intelligence. And so you have these drones that follow whale pods. And when a whale blows its nose, when it blows the blowhole, the drone swoops down, has petri dishes on it, collects that whale snot, the whale mucus. The AI then analyzes the contents of it. So it's looking at the water content, the kelp, the algae, the crustaceans, the bacteria, a whole bunch of things. And it's, even though it's analyzing all these different pieces, they're like a jigsaw puzzle. And the AI is constructing a jigsaw puzzle to see how healthy is that local ocean environment. This is not something that we as people could do easily and never really did before because it requires a lot of work. Ocean Health Alliance actually put this together, said that means if we try to do this as with people power, meant getting a boat, crewing it with 12 scientists, following them out. What this SnotBot does in a day would probably take them 14 days to do. So again, not something that we would intuitively think of, but they found a better way, a new way of doing it, tapping into that innovative thinking. Right, and that's what we have a lot of initiatives out there. Part of my work with the United Nations is helping them actually start the AI for Good initiative, where we're using this AI technology and actually other emerging technology for the Sustainable Development Goals. So if you're not familiar with them, they're things like ending hunger, ending poverty, providing better access to healthcare and justice. I won't bore you with all 17, but it's not, again, something that people intuitively thought of. So today we actually have over 116 projects going on. But you can see why AI can be a powerful force for social good. But there are challenges. I don't want to paint just a rosy picture and say this is a magic solution for all of us. There are things we have to be aware of, be alert, and monitor to use this technology properly and to make sure that we're trying to create good and not do harm. And the first and foremost is truth and trust in the technology. So I know you heard from the earlier speaker and previous speakers about concerns that people have, like, is AI going to take my job, right? That's not the goal, but some jobs will go away and some new jobs will get created. There's a lot of people that are worried what we call the Terminator scenario. Will AI become self-aware? Will it try and conquer the world and eradicate humanity? So there's lots of things that we have to be cognizant of. I know that even in my work, early work in AI, we were getting death threats all the time because they thought we were going to build that Terminator scenario. Thankfully, we didn't. We actually took safeguards against that. But one of the biggest threats we really need to be concerned about is actually bias. At the end of the day, AI is based off data and training. And while we're all trying to do good, there's things like implicit bias. There's these subconscious behaviors or stereotypes that we make that can unfortunately influence what we're doing. One of the big things the UN really wants to do is AI robot judges. They believe it'll improve access to justice, reduce corruption in the system, create more fairness, right? Could we do it? Yeah, we actually have a wealth of data. So you look at like the United States, there's actually tons of publicly available court data to tap into, but is there implicit bias in that system? And then unfortunately there probably is. If you actually look at the data, you'll see that people that commit the same crime get radically different sentences. Right, there's actually a recent case, unfortunately, where there are two people, same age, both student athletes, same sport, a lot of similarities, but one guy got 6 months of jail time, the other got 10 years. which means the AI is going to start wondering, like, what's the difference, and start wondering what's different about these two people. It may start thinking that, well, looking at all this data, it seems like some ethnicities get lighter sentences and some ethnicities get harsher sentences, and adjust its own algorithms to accommodate for that. So in fact, we're teaching the AI our bad habits. It's picking up our bias. So we have to be really cognizant about this. This means we have to be vigilant. We have to have a diverse and inclusive group of people checking our data and checking how we're training the machine. The other thing is we have to worry about corruption and fear. We always talk about people, process, technology. Unfortunately, we're not necessarily the best. Process is mature. We understand technology a lot better, but people still tend to be the challenge. If you look at the picture on the left, some of you may recognize this as the avatar for K-bot. This was a Twitter bot released by Microsoft almost 4 years ago, and they trained up an AI system to essentially be at the level of a 13-year-old girl. And it was going to be this grand social experiment in Microsoft's real foray into the AI space, saying, release her to everybody, she'll interact, K-bot will learn, right? K-bot's first tweet was, hello world, I can't wait to meet you. 24 hours later, Microsoft is shutting K-bot down. Because in that span, a small group, and it was a small group of people, taught K-bot to be racist, sexist, and a Nazi. So rather than this grand social experiment, you had a small segment of the population intentionally try and corrupt the AI system. So some hard lessons learned, but unfortunately, some bad people as well. On the right is actually an example from Facebook, where they were experimenting with their AI system, and they created 2 instances of it, and they had it chat with each other through Facebook Messenger just to see how this might interact. And this is real. You can see they're conversing in English, and suddenly, after a little bit, you see they have all this weird, looks like gobbledygook and stuff like that. The Facebook engineers didn't understand what was going on, so they shut everything down. They were trying to figure out what happened. 3 weeks into it, they brought in some linguists. The linguists took all this stuff and figured out that AI realized English is not an efficient language for them to use. And so they basically created their own shorthand language to converse. So this is the other challenge that we have with AI, is that sometimes we have engineers working on something that they don't fully understand. And that's a big thing. We can't be worrying about, like, if we're entrusting AI to make a recommendation or a decision for us, and they come back with something that seems odd, we have to understand how they arrived at that conclusion. We have the ability to build the technology into AI where it can explain its logic to us. It's just not something we do often enough. So that's something we really have to focus on as well. So all of this is something that we call responsible AI, making sure that we build technology that we understand, the explainability, the understandability, the looking for bias, and trying to use this for good use, AI for good, rather than just self-serving or something that might actually hurt people. So with that, I hope that you see that even though we probably will ban human drivers in the near future, it's not the end. I will, for one, actually look forward to that, because I'd rather be able to do something else in the car. I would definitely be far more productive. But I think there's an interesting partnership as we move forward. As people, AI it's a technology that's a tool for us. And if we can be innovative about it, tap into those new different ways, think differently about computers, we can unlock a lot of values for ourselves from it. With that, I thank you for your time. I hope this was useful. I'm not sure if I have time for questions or not. If I do, more than happy to take them. I'm sorry, there's like an echo, and I couldn't quite make out what you were saying.
No, I was just listening to the questions, to the audience questions you said. I tried to listen Thank you for the interesting and really thoughtful thinking. These are lectures appreciated, like responsibility and framework. I thank you.
Divya madam, few questions are there.
Oh, is it okay?
Yeah, so I will read out those questions for Neil.
Please.
Yeah.
There is time, please.
Yeah, so Neil, first question is from Tathagat Verma. He's asking, first he is thanking you for a very, very thought-provoking talk. He's asking question that what are the implications of cross-cultural mental models or nonsense in training AI systems, especially for companies with global products? What would it mean for a cross-cultural AI systems interacting with each other without human interventions, say for smart contracts or auto negotiation for delivering some autonomous services?
That's a great question, and it's actually something that's being worked on right now. So there are actually models that have been around for 50 years on how people negotiate. We actually know that different cultures, different countries have different negotiation styles. And because this is commoditized, we can actually teach the AI to negotiate, either as an assistant for a human or actually to try and run the negotiations. It's probably still a few years away. The interesting thing is, because right now we're using it to help people, that they're actually trying to integrate these cultural differences to help the human negotiators negotiate better. So understand the tactics, the strategy of that other negotiator based on cultural, as well as actually their individual negotiation style. In the future, there is the expectation that some of this will get fully automated. You'll have two AIs maybe negotiating over the price of a commodity, like steel or cocoa beans, whatever it might be. But it'll actually change the nature of negotiation in that we're no longer looking just at purely like cultural and style differences, but each AI, based on how it was actually trained in negotiation, will have its own unique style. And so we'll actually be looking at something I call machine psychology, where we'll have to teach ourselves and teach AI how to recognize the style of another AI system.
Thank you, Neil. One more question is there. The question is being asked on you have spoke about reduction, corruption and fear. So question is being asked, how AI can help in reducing corruption and fear?
Long term, it's us having our own personal AI digital assistant. That's kind of the peak that everybody has, an assistant that knows us really well and can speak to us. In the short term, it's really just more about actually getting quick wins, right? Using the technology, showing that it can do small things that we can trust it with. Actually, smart home systems are going to be a good example of that, and that we're going to trust the machine to, set the thermostat while we're out there, turn on the lights before we get home, temperature control, obviously safeguard our house. But I think it's going to take time. It's going to be a generational thing, because we see the younger generations much more open to using the technology. But I think one of the biggest things we can do is to make sure we're addressing the implicit bias challenge. That if we can create a little more visibility on how the AI is using data, how it got trained, we'll create more confidence us and people in using the technology.
Thank you, Neil. Thank you very much. If you are having any questions, or any panelist, if you are having any questions, you can directly ask. We are having, I think, 2 minutes of time more with him. Sunil, Narayanan sir, Chengappa, Krishna, anyone?
Narayanan, you can come out of the switch on your video.
Okay, so I think Neil, there are no more questions. So thank you very much for your thought-provoking. I think you were the person who directly came and told that you don't want human to be a driver. So, and when we are going to stop it. So that is really what we can say futuristic title. And we really appreciate the way you have made a very, very strong presentation about AI. I think over the last 2 days, what we have seen, everybody is telling AI is better. But I think you are the only person who told that AI is the best, even they can supersede the human intelligence and brain. So I think with this note, we can really now end this session. And we are now having a very, very strong opinion that yes, AI is going to be there and AI is going to be for good. So, and if we will use AI ethically, then definitely there is no better option than this. So with these words, I would like to thank you very much on behalf of IEEE Bangalore section as well as Bangalore Technology Conclave organizing committee. You can see all our program chairs, they are there to thank you. Thank you very much, Neil, and hopefully we will get you soon again in Bangalore in some other event.
I look forward to it. Thank you, everybody. Appreciate it.
Thank you, Neil. Thank you for a great talk.
So, Divya Madam, you can share our digital plate. So, everything is digital in this COVID world. So, even plates, thank you, plates, we are sharing you digitally.
Yeah. Bangalore Technology Conclave Organizing Committee and IEEE Bangalore section. We are promoting a couple of applications for the Please thank you. And thanks for joining us. Have a nice day.
Yes, so
over to police.
Thank you, Divya Madam. Thank you very much. I think before I conclude, I will request all the program chairs to share their feelings as well as experience in last 2 days. I know program committee has really worked from last 3 months to conceptualize and bring this really world class. I can say it's a world class event where speakers over there in the group. Hear from you. How was your experience this Bangalore Technology Conclave, which you would like to share with us, all the participants?
Yes. Good evening. And it's a marvelous experience. Organizing conference and executing was great for me. But you're working with the program chairs, and interacting you directly with you and coordinating so many speakers. I know directly I would not, but otherwise I'm aware of the activities. And personally, I am benefited. Anyway, you see, I took up with the organization. Maybe you already come and go. But it's our duty to take the lead for it and that is true in my case. Many times they ask why are you spending so much time in this type of thing? What do you get? You have to explain this interaction with others. You think what it is so many are talking with me, even in engineering or otherwise there. So I think I got opportunity to talk to members here and we learn how to do the publicity also, and of course, if you want to pursue conference, you have to dimension for the BTC. That is another dimension to our experience. And I thank everyone who is a part of the
Thank you, Divya Madam. Thank you very much. Sunil?
Yeah. It's my great pleasure to be associated with this esteemed program chairs. And then my different experience this time is, even though I conducted along with other program chair members previous years, almost like right from the conceptualization till the execution. But this time it is more like one tension is till the people join in the panel whether they have really any issues and all is extra pressure, I will say, because in a regular mode we know it and then they are in front of us and then last minute changes, it is up to us. But that is extra tension, I will say, in the virtual mode. But I think in the last 2 days we haven't slipped. Maybe we are overshoot by 5 minutes at the max, but we haven't missed out any of the schedule or all the speakers. I should thank whoever joining from different geography locations. They added value. And whatever the top company we can think of who is working in AI, we have in the panel. So, and panel or the keynote speeches, we are happy for that. I still remember 2 months ago or 3 months ago when we conceptualized, and then every week the 9 p.m. calls, and finally it resulted into a good experience. And some of them I know previously whom I were able to bring in, and some of the people whom I know well but never interacted. At least I had a chance to virtually interact. And the sessions are very diverse, right from it's not only the theoretical points or maybe the business points. We go into the deep technical aspects as well. So I'm sure the participants benefited well. And it's my great pleasure to be associated with this and looking forward for world-class events as such. And we are proving that virtually also we can do it. That's a great thing, actually. Thank you.
Thank you, Sunil. Thank you very much. Now over to Krishna. So I know you are really tensed about the US elections, but you please come out of it and let us know.
Yeah, I think this event came out very well. I echo the same what my colleagues told just now. We last 2 days we pulled out a lot of things, and AI means we covered a lot of areas, including like industry or advanced healthcare. All the areas we probably covered, very well covered, and very, very, very apt talks we had. So very glad to be part of this team, and hopefully in the future also IEEE Bangalore can do such a great, wonderful events. Thank you.
Thank you, Krishna. Now over to you, TV sir.
Thanks, Puneet. Thanks, everyone from Divya, Sunil, Krishna, Chengappa, Narayanan. Nice to see you here. Everyone, I think it's been great journey last 2 to 3 months to really work together as a team and really bring this whole thing to life. I think for me, even though I've been a long time volunteer at IEEE, it's been a long absence. So thanks to Puneet's push and nudge, I'm again back in the circuit, and I really enjoyed doing my contributions to that. I think it was a great learning more than anything else. One is in terms of working together as a team. Second is listening to all the experts coming with their point of views in terms of some of the sessions were very technical, technology oriented. Some of the sessions were very business oriented. Some of the sessions were very kind of, they leave you with a lot of questions. Like Neil's session was a very, I liked it. I like the sessions that actually leave you with a lot of questions rather than a ready-made cookbook answer. So I really enjoyed learning through most of the sessions that I was able to do. Great. I think it's a great turnout by the Bangalore section. I think, Puneet, we should definitely see what we can do even at India level and see how we can take this model there and really do something like AI for India or India for AI kind of a thing, because I think it's an opportunity, and IEEE can take a pole position in educating the members and general public to really bring some of these powerful ideas there. So thanks once again for a wonderful, I'm going to miss the Monday 9 p.m. slots now. But look forward to also catching up sometime when the COVID madness is over. Thank you. And thanks to Puneet for all the leadership in keeping us honest. And I think the majority of heavy lifting, I'm not ashamed to say, has been done by Puneet. I think we guys were just doing a little bit here and there, but I think, Puneet, you are the glue that kept us all together. So thanks for keeping us honest, and thanks for keeping us focused and aligned to the conference goal.
Thank you very much. So friends, with this, we are going to end our 2 days of this mega event, which was truly international. I don't have any other words that this is not being an international event, even though this is name is Bangalore Technology Conclave, and Bangalore is known for technology. So I think we have proved that whatever events or conclave we are organizing, they are truly world class. And you see, you name it, starting from Amazon, Flipkart, Walmart, HP, Google, anyone who is Ericsson, as well as our Newtonics. And then we are having quite, IEEE, it is because of this lineup of speakers when we approached to IEEE president, saying even though he is busy with IEEE board meetings, he could not deny us. He told that yes, even though for half an hour I will join, but I will join, and he has joined. And we are very proud to say that participants' registrations for this particular conclave was starting from Australia, and it went till Pakistan. So you can see entire Asia Pacific region, Sri Lanka, Bangladesh, everyone, China, and surprisingly even France, US, and Canada, there was a registration. So it means the program was really liked by the delegates, and because of some time zone issues, even though I know the speakers as well as Krishna was also struggling because of this time, but we tried to manage it 2 slots, morning and evening. And with that, we tried to accommodate some, we were not able to accommodate few really international speakers because of this time zone variations. But overall, I am really satisfied and contented. I can say that the way program has come out, even though we were trying from last several years to have this kind of impactful and industry-focused event, in Bangalore section we were doing, but that international stature as well as a really focused thing where who's who of the industry, they all are there at a single platform, which IEEE provides a kind of neutral platform which no one else can provide, and known for technology as well as. That's why when we chose the track for this event also, you can see it was a very, very well thought. I really appreciate the efforts made by all our program chair, who own each one of them own one track. So we focus that we are going to have first track on the present status of AI in industry. Then it was thought that, okay, once we will know that what is the status of AI in industry, let us see that what advances industry is going to do in future. So that's why second session was kept as advances in AI. After knowing what are the futuristic AI, again, IEEE is known for technology for humanity. Our tagline is technology for humanity. So we aligned the third track that, okay, once we know AI, we know what are the advances they are going to be in the AI, how we can align AI for social good. So that's why the third session was kept for AI for social good. And then when we are doing everything, when we are trying to remove the human intelligence with the artificial intelligence, we should not do, I think Dr. Narayanan sir has brought out really well that IEEE code of ethics, and IEEE believes that anything we should do, it should be ethical in nature. So that's why we thought that we will be concluding our program with a session on ethical in AI. Ethics in AI, and you can see all the 4 sessions, they were truly amazing, and we brought in diverse perspective, starting whether it is from academia, it is from industry, whether it is from venture capitalist, and we have given a platform for startups too. So you can see that we tried to brought in different diversified portfolios and people who can really provide a very, very holistic perspective on this. And with these words, I think we will meet again in Bangalore Technology Conclave 2021, even though I will be a past chair at that point of time, but definitely I will be looking forward that how next year Exicom is going to take over. I think Divya madam and Tathagar sir, Sunil, Narayanan sir, they all will be there. and they will be pulling up much better and much bigger version than this version. With this, thank you very much. And I still see participants are there and they are showing their thank you messages and appreciation for all the committee members. So I can, with these words, I would like to stop myself here. If any one of you is having anything, please. I think Neha and Chengappa, both of you, Neil also, please switch on your video camera so that for the last session, we can have a group photo and we can end the session here.
Puneet, I don't think AI can replace you. So.
I also want to thank Chengappa and Neha for those support. Otherwise, this would have been a bit difficult. Thank you.
Yeah, we are in the front end, but there are so many volunteers who are at the back end, without whom right from the digital flakes or the writing the notes, we do have lots of post processing, and we should thank everyone from that. And to your point, Puneet,
you are the only hard one out.
To your point, Puneet, we are setting high standards for ourselves and for our section, so we need to keep up. Is not an easy challenge for the upcoming XCOMs.
Yes. Yes. Fully agree with you. Okay, so this is the last snap I will be taking.
Neha, your video.
No, she has some problem with it. She updated me on the...
Okay. So, well, thank you very much. Yeah. And Neil, we will see you again in some point of time, Bangalore, very soon physically. Thank you.
Thank you, guys. Thanks, everyone.
Have a good day and good night.
Thank you.
Thank you.
Bye-bye, guys.
Bye. Bye-bye.